हेलो दोस्तों, स्वागत है आप सभी का इस चैनल पे। मेरा नाम है देवाशीष एंड दिस इज़ एन एड शार्पनर प्रोडक्शन। वेलकम बैक टू द चैनल। मुझे पता है हम आज ही मिले थे दोपहर एंड टुनाइट दिस टाइम वी हैव प्रदीप गाटकिने। ही इज़ फ्रॉम नासा. You all wanted somebody from NASA. Thankfully, Pradeep said yes, and we are so lucky to have him today. Pradeep Gatkine is a mechanical engineer. He did his Bachelor's of Technology from IIT Bombay, and he is currently NASA Hubble Fellow, who is hosted at Caltech, right, in US, of course. And he'll talk about astronomy. He'll talk about everything about his career. और आप आज खुल के सवाल पूछ सकते हो. ये जो पॉडकास्ट है ये ऐसे कोई टिपिकल पाथ या फिर ऐसा करो वैसा करो ऐसा नहीं है. यू कैन हैव डिफरेंट मेनी क्वेश्चंस एंड यू कैन आस्क देम. फील फ्री टू आस्क दोज क्वेश्चंस. ये थोड़ा नया सा चीज़ है इस चैनल के लिए भी. और हम वी डू नॉट मीट डेली somebody from NASA, right? So keep your doubts and share with us. मैं अभी क्विकली प्रदीप को शेयर करता हूँ. आई कुडंट लाइक इंट्रोड्यूस हिम अ लॉट बिकॉज उनके पोर्टफोलियो में इतना सारा है. It's better that we listen from him. And let me just quickly add him on the screen. Pradeep, now I think everybody can see you.
Yes.
And
Yes.
let's hope everybody can hear you as well. Welcome to Ed Sharpener.
Yes. And good morning, good evening, good night to wherever you are listening from. Really nice to have you.
Yeah, I hope everybody is from India. Maybe if you shared this video with somebody from US, maybe few people would be from US.
Yeah.
Few people will join in soon, but we cannot waste a lot of time. We do not have a lot of time. People will join and they'll keep asking their doubts.
Sure.
I'm really happy with this particular podcast is because, like I said, we do not meet somebody from NASA every day. And NASA is a big buzz, right? NASA is a big buzz. It's a different kind of a career. Astronomy is itself a different kind of a career. So really,
Yeah.
I'm feeling really thankful for this, that you said, yes, finally we're doing this. And of course, everybody wants to know, Pradeep, how does somebody decide to go into astronomy? What inspires somebody and all that? Could
Right.
you talk about that? कि
Yeah.
क्या था, मतलब सबसे पहले से लाइफ में यार एस्ट्रोनॉमर बनना है, कब से शुरू हुआ ये पैशन?
Right. So I'll give you like where I'm right now, and then we'll go backtrack from there. So I did my bachelor's in mechanical engineering at IITB, and then I completely switched gears and went to grad school in astronomy at University of Maryland. So matlab like 2014 I finished my undergrad at mechanical engineering, and then I started my PhD in astronomy at University of Maryland. So like in 2020 I finished my PhD in astronomy, and now I'm a NASA Hubble Fellow at Caltech. So that's like where I'm right now. And let's now go back like many years, rewind like 20 years.
When we were in the 12th standard.
Yeah, like 12th standard. Yeah, 2010 I think that was 12th standard. But even before that, like I think this sort of kida of astronomy, it started much early on. Like it was when I was maybe in my middle school or something, like 5th standard vagara. So and I started reading I somehow like I got hands on a book, astronomy book. It was about like planets and stars, and it was really fascinating. मतलब उसमें ऐसे ऐसे कुछ चीजें लिखी थी ना जो ऐसे it is literally otherworldly. I mean astronomy is literally otherworldly, but मतलब ऐसे ऐसे कुछ चीजें जो उसमें थी, like there were some things about like there is a storm on Jupiter, like the red storm, and it's like the size of Earth, and it's been around for like hundreds of years, and like there could be life on some like satellites of Jupiter and so on. Like मतलब ऐसे कुछ कुछ चीजें थी ना जो ऐसे like it was like completely out of the blue. You cannot imagine something like that. और मतलब of course उसके बाद I had this really nice opportunity to go to this Raman Science Center. So I grew up, I was born and brought up in Nagpur, and it was really nice to have something like a science center up there in Nagpur,
Yes.
which you could visit. And they also
These
had a
things help.
planetarium. Right, exactly. Yeah, and there was also a planetarium there, and there was this planetarium show which was just fascinating. Matlab, like you just lie down and you look at like this whole sky, and like it's
हाँ, मैंने भी
basically like
देखा
a
है, वो बहुत ही सही रहता है
movie.
यार.
Exactly, like it's like a movie in the dome, and matlab wo aise, it's just amazing to see something like that. And then they give you, they show you like this is how this is how the planets move, and then there are these constellations, and there are these other galaxies, and this is how life evolved on Earth and so on. मतलब it's just a fabulous experience. तो मतलब ऐसा
Right.
experience होता है, और फिर उसके बाद I got more involved with Raman Science Center. I also participated in many competitions that they organize. So they regularly organize competition. जैसे अभी
हम्म
28th of February is the National Science Day.
अच्छा.
So that's like one big thing. मतलब ये हर जगह, इंडिया में हर जगह इसके कुछ ना कुछ फंक्शंस चल ही रहे होंगे. तो
Yeah.
नेशनल साइंस डे, एंड देयर आर मेनी अदर थिंग्स. तो ऐसे टाइम टू टाइम देयर वर सम थिंग्स हैपनिंग देयर, और कॉम्पिटिशन्स वगैरह होते थे, तो उसमें मैं पार्टिसिपेट करता था, और उसमें जीतने के बाद बुक्स मिलती थी. और मतलब वो एक्चुअली सबसे पहला मेरा ऐसे एक्चुअल बुक पढ़ने वाला एक्सपीरियंस था, क्योंकि उससे पहले तो मैं ऐसे कुछ भी रैंडम कहानियां वगैरह कुछ भी पढ़ रहा था.
राइट
तो
राइट.
तब मतलब मुझे जो बुक्स मिली ना, जो साइंस की बुक्स और एस्ट्रोनॉमी की बुक्स जब मिली, और वो देवर सो नाइस बुक्स. मतलब वो एस्ट्रोनॉमी की बुक्स और मराठी में थी, और तभी मतलब मुझे मराठी में पढ़ना बहुत अच्छा लगता था. तो मतलब अभी भी लगता है, लेकिन मराठी इज माय मदर टंग, एंड आई लव टू रीड इन मराठी. तो मतलब मराठी में वो बुक्स थी और बहुत अच्छी थी, और वो पढ़ने के बाद मतलब ऐसे ऐसे कुछ कुछ चीजें पता चली ना जो इमेजिन ही नहीं कर सकते. मतलब जैसे there is an atmosphere around sun which is like a million degree Kelvin, and the surface of the sun is only 6,000 Kelvin. So the atmosphere is like hotter than the sun.
Hotter than the sun's surface.
Exactly.
Yeah.
And then all these comets that you see, they come from much 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 beyond Pluto's orbit. मतलब these are some of the things that I couldn't even fathom कि मतलब ये कैसे हो सकता है. और there is the temperature difference between between Mercury's day phase and the night phase, and
Right.
just the temperature difference between moons, our own moons, day phase and the night phase. It's just it's completely bizarre. मतलब it's 100, it's somewhere around 200 degrees Celsius. It is just completely
अच्छा,
bizarre.
अपना
मतलब
वाला मून, चांद.
exactly, yeah.
Really? I didn't know that.
Backyard.
Very interesting.
And there are these kind of plumes coming out of some satellites of Jupiter, and these plumes contain organic molecules and such. I mean, मतलब ऐसी चीजें कुछ उसमें से पता चली जो इमेजिन, मतलब ऐसा for example, you might imagine कि Earth's orbit around the Milky Way, Earth is in the Milky Way galaxy.
Yeah.
So you can imagine कि Earth's orbit around Milky Way must be a circle, but it's not the case. It's like this. It's like a sinusoid on top of that circle.
Oh.
And it has some implications on the this life
But is it
cycle on
because
Earth.
it revolves around sun? Is that?
No, it's actually
that it?
because the Milky Way is a disk, and you are actually moving along a disk, and when you move along a disk, you tend to get this kind of a pattern. तो मतलब you can imagine कि 7वीं और 8वीं में मतलब कोई बंदा पढ़ रहा है, and they come to know about this. मतलब they are like, what is happening here? It's just completely unimaginable. You have certain things in your mind कि you कि हाँ मतलब ऐसा जैसे stars के around planet जाते हैं, वैसे ही sun must be going around the center of Milky Way, and so, but that's really not the case. And so
sun is also going in the sinusoid.
The sun is going in that sinusoid, and that sinusoid has some implications on this life on Earth, basically. If sometimes there are certain phases, when Earth goes through Milky Way, there are certain phases when the many species start to go extinct. There are massive extinctions that happen on Earth, and then so they have some correlations there as well, in the evolution of life on Earth and motion of sun around Milky Way. मतलब these are the kind of things मतलब जो एकदम ऐसे bizarre kind of things है. And these are I really like and I really liked reading something like this. And मतलब जैसे एक 7-8 7th 8th स्टैंडर्ड के बच्चे के माइंड पे ना उसका असर होता है, जैसे
जैसे I am understanding.
हाँ, मतलब ऐसे ऑनलाइन गेम्स वगैरह खेलने के बाद लोगों के दिमाग पे कुछ असर होता है ना, तो ऐसी चीजें पढ़ने के बाद ना लोगों के दिमाग पे असर होता है, और वो हुआ मेरे दिमाग पे असर. एंड I got really interested in astronomy. So
this is so nice of you, Pradeep, कि you are admitting कि तुम्हारे दिमाग पे असर हुआ. Beautiful
Exactly.
story, bro.
And it was like, that's how I got interested in astronomy. And फिर 10th standard में there was a game changing event that happened. I got selected in astronomy olympiad. तो जो एस्ट्रोनॉमी ओलंपियाड की कंपटीशन होती है, लाइक देयर इज अ नेशनल स्टैंडर्ड एग्जामिनेशन इन एस्ट्रोनॉमी, आई थिंक इट्स कॉल्ड, देयर इज आल्सो लाइक फिजिक्स की भी वैसे होते, फिजिक्स, केमिस्ट्री, एस्ट्रोनॉमी, और भी मतलब है शायद, मुझे लगता है जूनियर साइंस करके एक है और वो भी होता है. सो देयर आर दीज नेशनल स्टैंडर्ड एग्जाम्स जो गवर्नमेंट कंडक्ट करती है. तो उसमें मुझे उसमें मेरा मतलब वो नेशनल लेवल पे सिलेक्शन हुआ, और फिर उसके बाद की एक लेवल होती है, दैट इज द कैंप. सो ऑल ओवर इंडिया से कुछ 30 लोग वगैरह उसमें सिलेक्ट होते हैं, और वो लोग को वो एक जगह पे बुलाते हैं और उन्हें ट्रेनिंग देते हैं एस्ट्रोनॉमी में. एंड लाइक वी सॉल्व वेरी इंटरेस्टिंग प्रॉब्लम्स इन एस्ट्रोनॉमी. लाइक फॉर एग्जांपल देयर इज लाइक अ सोलर कोरोना, लाइक मतलब सोलर एटमॉस्फेयर में से एक ऐसे कोरोना का एक पैकेट निकला, लाइक like the auroras and everything that we see, and like sometimes there is disturbances that happen in the electricity grid, that happens because of these solar storms. So ऐसे solar storm वहां से निकला, तो और like वो अर्थ की तरफ जा रहा है, तो how long would it take for it to reach earth? And it's not just based on like the acceleration or वगैरह, it's not just based on that, there is a lot more physics that goes into it.
Of course.
So like we were solving some really really interesting problems there. And it was it was a transformational experience for me. तो मतलब वो सब जो ट्रेनिंग वगैरह मिला, और and it was like for 20 days, so it was it was a lot of, like we crammed so much in our head over such a short time कि मतलब वो ऐसे एकदम concentrated experience था. And that was great. So that really helped me sort of get my mindset for astronomy. और फिर मतलब जब मैं 12th स्टैंडर्ड में आया, तब ऑफ कोर्स लाइक वी वर प्रिपेयरिंग फॉर आईआईटी, एंड मतलब देवाशीश्वर में सेम ही वो कोचिंग सेंटर
ट्यूशन में थे.
हाँ. और तो मतलब वो मतलब इट वाज, तब मैंने मतलब पूरा डेडिकेशन से आईआईटी के लिए प्रिपेयर किया था, और हो भी गया था.
सो दिस वाज लाइक अ बिहाइंड, ये थोड़ा पीछे पड़ गया था कि
हाँ, मतलब फिर एस्ट्रोनॉमी भी था बैक ऑफ माय माइंड, बट आई न्यू कि मतलब आई वांटेड टू गेट इनटू आईआईटी, एंड देन एस्ट्रोनॉमी विल कम एट सम पॉइंट.
वो डिसाइड कर लिया था पहले ही?
हाँ, मतलब ऐसा मेरे माइंड में था. तो जब मैं आईआईटी में सिलेक्शन वगैरह होने के बाद सिलेक्ट कर रहा था कि ब्रांच कौन सी लेनी है, तो मतलब ऑफ कोर्स जैसे सब लोगों के दिमाग में ऐसे क्वेश्चंस होते हैं, तो वैसे मेरे भी दिमाग में क्वेश्चंस थे कि कौन सी ब्रांच लेनी है, कहाँ पे, और वो जैसे पेरेंट्स वगैरह का वो भी होता है कि कहाँ पे जॉब अच्छी मिलेगी वगैरह. तो एक तो मैं ये बता रहा हूँ कि मतलब आईआईटी में जो भी ब्रांचेस है उन सबका स्कोप है, इसीलिए वो ब्रांचेस आईआईटी में है. मतलब देयर इज नो ब्रांच इन आईआईटी कि जिसमें कोई स्कोप नहीं है. मतलब सिविल इंजीनियरिंग भी अगर लिया, तो सिविल इंजीनियरिंग में देयर आर सो मेनी चैलेंजेस, लाइक फॉर एग्जांपल like you want to build a मतलब climate resistant buildings nowadays, you want to build like these different kinds of challenges in our world right now. So there are different kind of challenges need different kind of solutions. So
right,
every engineering is, there is a lot to do in every kind of engineering. तो मतलब ऐसे मत सोचो कि अरे मेरा तो मेटा में हो गया, लाइक मेटलर्जिकल इंजीनियरिंग में हो गया, या फिर मेरा मटेरियल साइंस में हो गया. एक्चुअली मटेरियल साइंस इज such a hot field in the US right now. Like it's one of the like ऐसे national importance की field है. So
but are you saying research wise or like really jobs wise?
No, even jobs wise, like there is such a shortage of skills in in metallurgical, like जैसे अभी lithium is on the rise, right? Like and there are many other rare earth elements that are required for all the technology that we use. तो मतलब ये सभी branches, like every branch has a lot to contribute. Has a lot to contribute, and there is a lot of मतलब research, there is a lot of job opportunities and so on happening. तो मतलब ऐसे मत सोचो कि मेरा इसमें हो गया तो बस अभी हो गया, मतलब like my opportunity is gone. No, your opportunity has just begun. मतलब you have to get started now, like you have to look with like a very positive mindset और सोचो कि इसमें क्या-क्या challenges है और क्या-क्या उसमें कर सकते हैं. तो ये तो एक था मतलब कि कौन सी ब्रांच सिलेक्ट करनी है, और वो भी था कि कौन सा इंस्टीट्यूट सिलेक्ट करना है, वो भी होता है. मतलब हमको लाइक इंडिया में ऐसा है कि हमें प्रेफरेंस लिखना पड़ता है और उसमें मतलब ब्रांच और लाइक ब्रांच भी लिखनी पड़ती है और इंस्टीट्यूशन भी लिखना पड़ता है प्रेफरेंस में. तो अभी ऐसा है कि उसमें लाइक you know I really wanted to go to IIT Bombay, क्योंकि जब ये मैंने एस्ट्रोनॉमी ओलंपियाड का कैंप बताया था ना, वो IIT Bombay में हुआ था, तो मुझे IIT
अच्छा
Bombay मैंने अंदर से देखा था और मुझे
ओके वैसे आईआईटी बॉम्बे इज अ कूल बस ब्रो, वो तो वहां
हाँ
पे हर कोई जाना चाहता है एनीवे
एग्जैक्टली।
वहां पे था
तो
ही वो
तो मतलब मुझे IIT बॉम्बे में जाना था, तो मैंने प्रेफरेंस में वही लिखा कि मतलब IIT बॉम्बे मैकेनिकल इंजीनियरिंग, और सेकंड मैंने लिखा था IIT बॉम्बे इंजीनियरिंग फिजिक्स, क्योंकि मुझे मतलब फिजिक्स और एस्ट्रोनॉमी, जो मैंने बताया था ना कि एस्ट्रोनॉमी में इंटरेस्ट हमेशा से ही था, और मुझे ये तो करना ही था कि एट सम पॉइंट आई वांट टू गेट एस्ट्रोनॉमी इंटीग्रेटेड इन माय थिंग। तो
ओके
मैंने सोचा
बट
कि
व्हाई
फिजिक्स
मैकेनिकल एट द फर्स्ट दो, सॉरी टू इंटरप्ट,
हाँ हाँ
मैकेनिकल
हाँ
पहले क्यों? हाँ
एग्जैक्टली तो फिर मैं सोच रहा था कि फिजिक्स से रिलेटेड कौन सी ऐसी चीज है, और जो जिसमें मुझे इंजीनियरिंग का भी नॉलेज मिल जाए और फिजिक्स का भी मतलब मुझे ठीक ठाक सा नॉलेज मिल जाए। तो मैं इस
हम्म
तरीके से सोच रहा था। तो इंजीनियरिंग फिजिक्स एक ब्रांच थी, और मैकेनिकल इंजीनियरिंग मुझे ऐसा लग लाइक तभी मेरा जो पर्सपेक्टिव था उसमें से मुझे ऐसा लग रहा था कि मैकेनिकल इंजीनियरिंग में बहुत सारा फिजिक्स होगा। और एक्चुअली मेरा भाई भी तभी मैकेनिकल इंजीनियरिंग कर रहा था, और उसमें मैंने बुक्स वगैरह देखी थी, पढ़ी थी, और मैंने ऑनलाइन भी थोड़ा रिसर्च किया था कि अलग अलग ब्रांचेस का क्या क्या
हालत है
कोर्स मटेरियल इन द सेंस लाइक उनका क्या क्या करिकुलम होता है। तो उस टाइम ऐसे घर पे इंटरनेट तो नहीं होता था। देयर यूज्ड टू बी समथिंग कॉल्ड इंटरनेट कैफेज in 2010. So this
हम्म
is for the younger people who might be seeing. There used to be an entity called internet cafes कि जहाँ पे लोग
अरे
जाके
बताओ यार लोगों
इंटरनेट
को,
सर्च
इतने भी पुराने लोग नहीं है उसे व्यूअर्स में।
मतलब आजकल तो ऐसे इंटरनेट इतना ज्यादा है जियो वगैरह के, बट एनीवे। सो I you know did a lot of research on internet कि मतलब क्या क्या करिकुलम है अलग अलग ब्रांचेस का, और उससे फिर पता चला कि मैकेनिकल इंजीनियरिंग हैज अ लॉट ऑफ ओवरलैप विद फिजिक्स, सो दैट्स व्हाई आई सिलेक्ट। और मैंने मैकेनिकल इंजीनियरिंग पहले इसलिए डाला था क्योंकि मतलब देयर वाज दिस थिंग ऑन द बैक ऑफ माय माइंड कि जैसे इंजीनियरिंग फिजिक्स के बाद क्या क्या हो सकता है, ये मुझे पता नहीं था उस टाइम।
या
ये तो मतलब ये
ओके
तो बात का इट्स लाइक अ मोर रेट्रोस्पेक्टिव थॉट कि हाँ इंजीनियरिंग फिजिक्स में भी इतनी सारी अपॉर्चुनिटीज है, ये तो इट्स अ रेट्रोस्पेक्टिव थॉट, लेकिन उस टाइम मुझे इतना सारा नहीं पता था। तो मैंने फिर मैकेनिकल इंजीनियरिंग फर्स्ट डाला और सेकंड इंजीनियरिंग फिजिक्स डाला, दोनों आईआईटी बॉम्बे में ही डाला, क्योंकि वो मतलब आईआईटी बॉम्बे में जाने का बहुत
गॉट इट
मन था। और एंड द अदर रीजन फॉर मैकेनिकल इंजीनियरिंग वाज आल्सो बिकॉज़ आई वाज इंटरेस्टेड इन रोबोटिक्स। तो
या
जब जैसे मैंने ये एस्ट्रोनॉमी के अलग अलग चीजें देखी थी, तो रोबोटिक्स की भी मतलब जैसे रोबोकॉन वगैरह होता था ना, तो वो ऐसे नेशनल डीडी न्यूज पे आता, डीडी वन पे वगैरह आता था उस टाइम, मतलब हम लोग देखते थे, और
गॉट
वो
इट
बहुत
ओके
अच्छा था। और लाइक ऐसे स्पेस के लॉन्चेस वगैरह देखते थे, सो मैकेनिकल इंजीनियरिंग वाज काइंड ऑफ रिलेटेड टू दैट। सो आई वाज लाइक कि हाँ ये लेते हैं मैकेनिकल
तो अभी
इंजीनियरिंग।
मतलब लाइफ सेट ही आईआईटी बॉम्बे में मैकेनिकल में आ चुके हैं, अभी हम आगे
हाँ
बढ़ते हैं, मतलब लाइक आई विल आस्क यू अबाउट द प्रोजेक्ट्स एज वेल। उसके बाद मेरे को बहुत इंपॉर्टेंट चीज़ पूछनी है, लेट मी जस्ट क्विकली गो थ्रू सम ऑफ द कमेंट्स, वो एक बार देख लेता हूँ इन विच डायरेक्शन आर व्यूअर्स आर आस्किंग द क्वेश्चंस। गुड इवनिंग, हेलो एसके, हेलो निरंजन। अभिषेक पूछ रहे हैं लॉन्ग टाइम नो सी, अरे मैं हाँ थोड़ा सा मैं बिजी था, लेकिन वी आर बैक, नाइस टू सी यू अगेन। Gajodhar, sir, what is the scope of environmental engineering in USA? Okay, we will ask that. No worries. Somebody is asking, I want to do masters in applied mathematics. Would I have any scope in any space industry? Okay, we'll get to that as well. ये
हाँ
चीज़ें हम कवर करते हैं. The
एब्सोल्युटली।
next thing that I would like to ask you, Pradeep, मतलब वो तो है क्वेश्चन में, it's about the projects that you did. But next, I'll like to ask that before. A big barrier for many people is like, yes, okay, इंडिया में से यार चलो बीटेक कर लेंगे, आईआईटी से बीटेक कर लेंगे, इंजीनियरिंग कर लेंगे, then you jumping into astronomy, okay, somebody having that passion, everything. I think did you write GRE exam, or was there any other path, or are there any other paths of having that kind of a PhD in a good institute? Could you
राइट
like shed some light upon the ways in which like you can really land up such PhDs or
राइट
masters in
राइट राइट
outside India?
राइट। तो मतलब ऑफ कोर्स लाइक आई मूव्ड फ्रॉम मैकेनिकल इंजीनियरिंग टू एस्ट्रोनॉमी, सो दैट्स अ बिग जंप, क्योंकि मतलब इंडिया में ऐसे एस्ट्रोनॉमर्स है जिनको ऐसे बताया कि मैं मैकेनिकल इंजीनियरिंग कर रहा हूँ और उसके बाद मुझे एस्ट्रोनॉमी में करना है, तो वो बोलेंगे मत करो, क्योंकि
Hmm.
मतलब लाइक इट्स सच अ बिग जंप कि मतलब दे कैन नॉट इवन इमेजिन समथिंग लाइक दैट हैपनिंग कि कोई किसी ने
Hmm.
मैकेनिकल इंजीनियरिंग स्टडी किया और उसके बाद एस्ट्रोनॉमी में जा रहा है। सो
Yeah.
of course it takes a lot of preparation, मतलब it's not just everything that you do in your last year but it's also things that you do before that। तो
Hmm.
जैसे पूरे इंजीनियरिंग में ही मतलब मैंने हमेशा ऐसा एक्टिवली ट्राई किया कि आई शुड गेट मोर नॉलेज, like more formal knowledge about astronomy and more experience, research experience in astronomy. तो जैसे
ओके,
हर साल समर और विंटर वेकेशन में मैं कुछ एस्ट्रोनॉमी की इंटर्नशिप करता था, मतलब एवरी
अच्छा।
समर एंड विंटर इंटर्नशिप. So I had done like 6-7 projects by the time I applied for, like at least 6 projects or so by the time I applied for grad school in astronomy. So I had a research portfolio of myself. तो मतलब
ओके।
वो एक था एक्सपीरियंस, था रिसर्च का एक्सपीरियंस. दूसरी एक चीज होती है कि व्हाट इज योर कोर्स प्रिपरेशन विच इज मोर गियर टुवर्ड्स दैट पर्टिकुलर ब्रांच. तो जैसे एस्ट्रोनॉमी में फिजिक्स और मैथ लगता है, मैथ तो इंजीनियरिंग में बहुत सारा है, लाइक इट्स
राइट।
फुल ऑफ मैथ. ओके, मैकेनिकल इंजीनियरिंग इज फुल ऑफ मैथ, so you
यस।
get a lot of math experience anyway. But physics experience, I did a minor in physics, so that means I did like several extra courses. It's like 5-6 extra courses in physics from various like classical mechanics, quantum mechanics, thermodynamics वगैरह, ये वो ऐसे बहुत सारे courses. Like you can do these extra courses क्योंकि undergrad में बहुत time होता है अपने पास. You can do extra courses, मतलब even if you
हाउ
think
डिड
that
यू डिसाइड प्रदीप कि यार ये कोर्स एस्ट्रोनॉमी में काम आएगा, लाइक बिकॉज यू न्यू दैट बिफोर, राइट? कि हाँ
uh,
ये।
हाँ, मतलब ऐसा है कि उस टाइम आईआईटी में देयर वाज दिस फिजिक्स माइनर दैट दे वर ऑफरिंग. तो फिजिक्स माइनर में देयर वर अ सेट नंबर ऑफ कोर्सेज कि उसमें से भी कोई भी 5 आप कर सकते हैं. लाइक देयर वर लाइक एन
ओके।
नंबर ऑफ कोर्सेज दैट दे ऑफर्ड, उसमें से कोई भी 5 आप कर सकते हैं. सो
या।
आई ट्राइड टू टेक द वाइड सैम्पलिंग ऑफ फिजिक्स एज मच एज पॉसिबल. मतलब जैसे लाइक पार्टिकल फिजिक्स या thermodynamics and like classical mechanics, these are the things that are useful anywhere, like quantum mechanics वगैरह, these are the things that are useful in any branch of physics. तो मतलब ये मैंने इस तरीके से सिलेक्ट किया कि this is like a wide sampling, will
या।
take that with, I'll take that knowledge with me, और वो कहीं पे भी काम आ सकता है. मतलब एस्ट्रोनॉमी में नहीं तो और भी कहीं तो काम आ ही जाएगा वो. तो इसलिए that's how I took that. But I also did a lot of extra courses in electrical engineering which also helped my astronomy thing. तो जैसे
अच्छा।
इंजीनियरिंग, इलेक्ट्रिकल इंजीनियरिंग, मतलब एक्चुअली मैंने इलेक्ट्रिकल इंजीनियरिंग में शायद ज्यादा कोर्सेज लिए एज कम्पेयर टू द कोर्सेज आई टुक फॉर फिजिक्स. मतलब ऐसे लाइक बाय द डे आई वाज लाइक मैकेनिकल इंजीनियरिंग एंड मैकेनिकल इंजीनियर, एंड बाय द नाइट आई वाज लाइक इलेक्ट्रिकल इंजीनियर. तो मतलब ऐसे वो
कोर्सेज
सारे
ऐसे
रात
शफल
में
हो रहे
कोर्सेज, ऐसे शाम
हैं,
में
राइट।
कोर्सेज होते थे वो, लाइक ऐसे 6 to 8 वगैरह, ऐसे रात में शाम में कोर्सेज होते थे. और मैं वो लेता था क्योंकि मुझे इलेक्ट्रिकल इंजीनियरिंग में भी बहुत इंटरेस्ट था, और एक्चुअली सम ऑफ दैट वाज वेरी यूजफुल फॉर एस्ट्रोनॉमी एज वेल. मतलब वो ऐसे सोच के नहीं किया था मैंने, लेकिन इट टर्न्ड आउट दैट वे कि जो इलेक्ट्रिकल इंजीनियरिंग में भी मैंने कोर्सेज किए थे वो भी यूजफुल थे. जैसे आई डिड लाइक सम रेडार इंजीनियरिंग, रेडिएटिव सिस्टम्स वगैरह. तो ये सारी चीजें रेडियो एस्ट्रोनॉमी में बहुत डायरेक्टली रिलेटेड है. मतलब जैसे टेलीकम्युनिकेशन इलेक्ट्रिकल का होता है एंटेना से, तो वैसे ही रेडियो टेलीस्कोप भी एंटेनास ही होते हैं. So it's
राइट।
like it's directly connected. And then digital analog electronics and digital signal processing and such, all of that is, मतलब एस्ट्रोनॉमी ऐसी फील्ड है कि जिसमें सब कुछ यूज होता है, सब कुछ यूज होता है. इसमें मैकेनिकल इंजीनियरिंग भी यूज होता है, इलेक्ट्रिकल इंजीनियरिंग भी यूज होता है, उसमें सब कुछ यूज होता है. सो इट वाज इट वाज अ वेरी नाइस लाइक सॉर्ट ऑफ कोर्स का मटेरियल भी जो मैंने किया था, तो वो भी एक अच्छा था. फिर जो रिसर्च का भी मैंने अपॉर्चुनिटीज यूज की थी, जैसे एवरी समर विंटर आई वुड डू समथिंग रिलेटेड टू एस्ट्रोनॉमी, सो वो भी एक था. और तीसरा फिर जो फाइनल ईयर में हम लोग प्रिपरेशन करते हैं, जैसे जीआरई,
राइट।
फिर उसमें एस्ट्रोनॉमी है तो एस्ट्रोनॉमी में फिजिक्स जीआरई भी लगता है.
अच्छा। ओके।
अनदर एग्जाम, फिजिक्स जीआरई इज अनदर, इट्स सॉर्ट ऑफ लाइक जेई, मतलब जेई या एआई ट्रिपल ई का
अ
जैसा पेपर
सप्लीमेंट
होता
फॉर
है,
एन
उसमें
एग्जाम।
100 क्वेश्चंस होते हैं. 100 क्वेश्चंस होते हैं उसमें, और ऐसे 2 या 2.5 घंटे ऐसा कुछ तो टाइम होता है. बेसिकली 2 आवर्स, लाइक 1 मिनट वन क्वेश्चन सॉर्ट ऑफ, उतना
ओके।
स्किल होता है. और मतलब कंसेप्चुअल क्वेश्चंस होते हैं उसमें. सो देयर इज लाइक अ फिजिक्स जीआरई एज वेल.
अच्छा।
तो वो सब मैंने किया, और फिर एस्ट्रोनॉमी में अप्लाई, मतलब जो नॉर्मली ग्रेड स्कूल में यूएस में अप्लाई करने के लिए लगता है, तो यू नीड द स्टेटमेंट ऑफ पर्पस, यू नीड द रिकमेंडेशन लेटर. और हाँ, मतलब वो रिसर्च एक्सपीरियंस का ये भी एक और फायदा है कि यू गेट द रिसर्च, मतलब रिकमेंडेशन लेटर्स फ्रॉम astronomers. Like I mean,
ओके।
in my case, I could get recommendation letters from astronomers as well. I mean, I got some from my professors as well from mechanical
ओके।
engineering. लेकिन astronomers भी है, उनका भी मुझे
जरूरी
उम्मीद.
होता है लेकिन
हाँ,
वो उनसे भी
एग्जैक्ट.
रिकमेंडेशन।
हाँ.
ओह।
और मतलब जो मैंने फाइनल ईयर में मेरा बीटेक प्रोजेक्ट किया था ना, वो ऐसा था कि मतलब वो एस्ट्रोनॉमी में एकदम it was steeped in astronomy, I would say. मतलब
अच्छा
it is you cannot imagine actually doing something like that in mechanical engineering कि mechanical engineering का bachelor's thesis का project ये हो सकता है, लेकिन
अच्छा व्हाट
वो
वाज द
मैंने किया.
प्रोजेक्ट
So so it was actually designing a cosmic ray payload for a balloon, for a balloon launch. So basically we launched these weather balloons. मतलब हम हर सिटी में एक्चुअली ऐसे वेदर बलून्स, हर सिटी या मतलब हर मेजर सिटी में ऐसे ऐसे वेदर बलून लॉन्चेस होते हैं जो जिसमें कुछ ऐसे वेदर वगैरह से रिलेटेड उसमें इंस्ट्रूमेंट्स रहते हैं, सेंसर्स वगैरह, लाइक यू नो दे हैव द टेम्परेचर, ह्यूमिडिटी, wind speed, they have the GPS, and they have like maybe like carbon dioxide का concentration detect करने के लिए. So they have like a few sensors in it. It's called radio sonde,
अच्छा
or radio sonde. That's what it's called. It's like very lightweight thing. And because it's very lightweight, it can be flown using a balloon, and that balloon reaches a height of 40 kilometers. So 40 kilometers is like near space. It's called near space.
अच्छा
It's like way into the stratosphere. So it's मतलब अगर वहां से कोई पिक्चर लिया ना तो ऐसे अर्थ ऐसे स्पेस के डार्कनेस में ऐसे, हाँ स्पेस के डार्कनेस में ऐसा अर्थ क्राउडेड दिखता है. वो यूट्यूब पे सर्च करना, यू कैन सी, यू कैन फाइंड आउट कि नियर अर्थ कैसे होता है, लाइक हाउ डज नियर अर्थ लुक लाइक. And so that's how it is, like you get to that kind of atmosphere with just a balloon. मतलब you can imagine कि मतलब बहुत सारे जो स्पेस से रिलेटेड सेंसर्स वगैरह हैं उनका भी टेस्टिंग ऐसे कर सकते हैं. तो आई डिजाइंड अ कॉस्मिक रे पेलोड कि कॉस्मिक रेस मेजर करने के लिए आई डिजाइंड अ वेरी लाइट वेट पेलोड फॉर दैट कैन बी फ्लोन ऑन अ बलून. तो मैंने सब कुछ उसमें किया, मतलब उसमें डिजाइन से लेके कम्युनिकेशन प्रोटोकॉल से लेके इलेक्ट्रॉनिक्स से लेके एवरी सिंगल थिंग आई डिड इट by myself. So that was and that project was completed. और जब फाइनली मतलब जब मैंने फाइनल ईयर के फाइनल मंथ में जब उसका लॉन्च होना, तब मतलब मुझे इतना अमेजिंग फीलिंग हुआ कि मतलब आई वाज लाइक आई लॉन्च्ड अ बेबी इनटू स्पेस, ऐसा कुछ. लेकिन इट वाज दैट काइंड ऑफ एन एक्सपीरियंस फॉर मी कि मतलब मैंने उस पर बहुत अच्छा एक फेसबुक पोस्ट भी लिखा, बट इट वाज बेसिकली इट वाज लाइक launching a part of yourself into space. So it was a very rewarding experience for me, and thanks to all the professors. Like there was one professor in mechanical engineering and one professor in physics that I went to them with this idea, and I said like I want to do this, and they approved thankfully. मतलब ऐसे ऐसे उन्होंने नहीं कहा कि हाँ नहीं mechanical engineering क्या है इसमें वगैरह. They didn't say any of that. They said okay, this is a great idea, we'll do this. तो
they probably knew कि इसके दिमाग पे असर हो चुका है, so we cannot say no. Probably
और
that,
actually,
but yes,
मतलब वो जो प्रोफेसर थे जो मैकेनिकल इंजीनियरिंग के, तो वो एडवांस फ्लूइड डायनामिक्स पढ़ाते थे. तो वो भी ऐसे जियोफिजिक्स वगैरह के फिनोमेना में वो भी इंटरेस्टेड, लाइक ही वाज इंटरेस्टेड इन वेदर पैटर्न्स एंड लाइक जियोफिजिकल फिनोमेना एंड stuff like that. So it was, in a sense, it was like a related thing कि मतलब वेदर बलून से लॉन्च करना है तो like we are building a payload for the weather balloon, and then the cosmic rays have some impact on cloud formation and such. तो मतलब उससे हाँ मतलब there was some connection. I was able to make a connection with him कि मतलब हाँ it has some impact on cloud formation वगैरह, so we'll do this. तो he was like okay, we'll do this. तो actually मैंने एक और चीज किया था mechanical engineering. I did honors in mechanical engineering, which means you do a few extra courses in mechanical engineering itself. तो मैंने fluid dynamics पे and advanced fluid dynamics पे वो courses किए थे कि जिससे मतलब मुझे वो भी एक knowledge मिले. एस्ट्रोनॉमी में fluid dynamics भी बहुत यूज होता है, मतलब ये सारे मिल्की वे वगैरह, like all these galactic simulations and all, these are basically a fluid dynamic simulation.
Amazing. Okay.
It's all very useful in astronomy. तो मैंने वो fluid dynamics का कर लिया और फिर ये project मैंने कर लिया. तो it was मतलब like after putting all this together, I think I was very confident कि कहीं तो मेरा selection हो ही जाएगा, मतलब astronomy में. And that came very soon, like the selection also, everything came very soon. So it was मतलब I didn't have too much to think about backups. I did have some backups though, even.
Yeah, let's talk about that. So मतलब as an IIT Bombay graduate, what were your options? कुछ job offers थी हाथ में और कहीं PhD लग रही थी, or you wanted PhD in Maryland only?
राइट. सो जैसे मैरीलैंड में पीएचडी का तो एक बहुत बड़ा फायदा है कि मैरीलैंड इज वेरी क्लोज टू डीसी. इट्स लाइक लिटरली ट्रेन राइड, लाइक 20 minutes ट्रेन राइड अवे. एंड मतलब ऐसे दिल्ली और गुड़गांव वगैरह ये ऐसा कुछ होता है ना, लाइक दोस दैट काइंड ऑफ अ थिंग. इट्स लाइक सबर्ब बेसिकली. Maryland,
yeah.
like जो College Park है, is basically a suburb of Washington DC, and Maryland also has NASA Goddard Space Flight Center. सो जो
ओके
नासा का जो एक्चुअल मेन सेंटर है जहाँ पे ये सारे स्पेस टेलीस्कोप JWST वहाँ पे बिल्ड हुआ, जेम्स वेब स्पेस टेलीस्कोप जो है वो वहाँ पे
यस यू
नासा
टोल्ड
गॉर्डन
मी
में मेरीलैंड में बिल्ड हुआ. सो
अमेजिंग
एंड देयर आर मेनी अदर टेलीस्कोप्स लाइक जैसे एक नेक्स्ट जनरेशन जो टेलीस्कोप है JWST के बाद जो आने वाला है अभी कुछ सालों में,
कौन सा है वो नाम बताओ
इट्स
यार
कॉल्ड सो इट्स कॉल्ड W फर्स्ट, लेकिन उसका जो एक्चुअल ऑफिशियल नेम है इट्स नैंसी ग्रेस रोमन स्पेस टेलीस्कोप.
ओह
सो रोमन टेलीस्कोप कहते हैं उसे, रोमन रोमन स्पेस टेलीस्कोप.
ओह
सो रोमन
जेम्स वेब
स्पेस
से कितना
टेलीस्कोप
ज़्यादा पावरफुल होगा
so it has a different power. It's not bigger than James Webb. It's actually
ओके
smaller than James Webb. It's
अच्छा
more like
साइज
the
वाइज
size of Hubble. Like it's like 2 meters in
अच्छा
diameter. Hubble is
हम्म
it's like 2 meters in diameter, and James Webb is 6 meters in diameter. So it's a smaller telescope, but it has a very wide field of view. So it can
हम्म
do like a lot of like for example जैसे
हम्म
पूरी galaxy को एक ही बार में वो image कर सकता है, and it can study it many times. Like that's
द
the
नेम ऑफ
power
इट
of
इज नैंसी
Nancy Grace Roman
नैंसी
telescope.
ग्रेस
Yeah, Roman telescope. Yes, if you
I'll
search
remember
Roman
that okay
telescope, Roman
cool cool
telescope,
let's
you will
go
find
ahead
that.
go ahead yeah
So
go
they
ahead yeah
have, they are building many things there. Like it's
yeah
just a full of exciting projects. मतलब like NASA Goddard is full of exciting projects. तो मतलब
okay
मुझे ऐसा था कि हाँ मतलब यार ऐसी कहीं यूनिवर्सिटी में जाना है जहाँ से बहुत अच्छा कोलैबोरेशन हो नासा के साथ. एंड
so you
आई
you
वर्क.
researched that well before
हाँ
going into
मतलब
there
you have to research that, right? Like you if you are deciding कि कहाँ पे अप्लाई करना है PhD के लिए, so you will decide pros and cons of
of
every
course
university, है ना.
hmm.
So I of course took a list of like what are the top schools in astronomy, और उसमें
Hmm.
से मतलब ठीक है मुझे लगता था कि हाँ इन स्कूल्स में मुझे अप्लाई करना चाहिए, क्योंकि
yeah
मैंने वहाँ के जो ग्रेड स्टूडेंट्स हैं अभी के, तो उनकी मैंने
hmm.
प्रोफाइल्स देखी थी. तो
अच्छा
उनकी प्रोफाइल और मेरी प्रोफाइल को मैंने कंपेयर किया कि मतलब वहाँ के फर्स्ट ईयर ग्रेड स्टूडेंट्स और मेरी प्रोफाइल में क्या सिमिलरिटीज है, क्या डिफरेंसेस है, कैन आई एक्चुअली
अरे
मेक इट
मेरी तो
देयर.
बहुत अच्छी है राइट
कैन आई एक्चुअली मेक इट देयर. तो मतलब ये सारी चीजें कंसिडर करके आई अप्लाइड फॉर लाइक अबाउट 10 ग्रेड स्कूल्स. तो उसमें से मुझे 3 में मेरा एक्सेप्ट हुआ था. बिकॉज आई मीन इट
ओके
वाज, यू कैन इमेजिन कि मैकेनिकल इंजीनियरिंग से एस्ट्रोनॉमी में जाना इज अ बिग स्टेप.
बिग स्टेप या
एंड मतलब इट इज अ बिग स्टेप फॉर द यूनिवर्सिटीज एज वेल, कि मतलब जब वो ट्रांसक्रिप्ट वगैरह देखते हैं एंड दे सी कि हाँ मतलब मैकेनिकल इंजीनियरिंग है, हाँ दैट इज स्ट्रेंज, एंड देन दैट वुड बी
अच्छा
देयर
देन
देयर
द
फर्स्ट थॉट.
रिंग
हाँ
रिंग
हाँ, देन उसके
ओके
बाद में फिर बाकी की सारी चीजें मतलब एसओपी वगैरह तो बाद में आता है ना, पहले तो यही देखेंगे कि
यस
बंदा कौन सी ब्रांच से अप्लाई कर रहा है. एंड सो so it was a big jump, but I still got selected in like Maryland, which is a very like it's like top 10 top 12 kind of schools in astronomy in the US. So it's
oh
exactly. So because it's so close to NASA, there is a huge collaboration between like NASA and Maryland. So मतलब there was just no question कि मतलब
yeah
it was a great school for me. So I applied there, and I applied to a few other, like Hawaii. I applied to University of Hawaii as well, and that's just because a lot of the big telescopes, like the biggest telescope on Earth, the Keck telescope, it's like a 10
अच्छा
meter diameter telescope. जो Keck telescope मतलब बहुत सारी डिस्कवरीज ऐसे Keck telescope से, जैसे अभी नोबेल प्राइज मिला था एंड्रिया गेज को. इस वाज लास्ट ईयर. सो 2020 का जो नोबेल प्राइज मिला था एंड्रिया गेज, शी एक्चुअली डिड the research, like the black hole ka jo research, like the orbits around black hole and everything. She did that research with the Keck telescopes. So and the
अच्छा
Keck telescopes are in Hawaii.
अच्छा
तो मैंने हवाई में भी अप्लाई किया था, यूनिवर्सिटी ऑफ हवाई,
ओके
और बहुत सारी मतलब जगहों पर अप्लाई किया था, एंड आई गॉट सिलेक्टेड इन 3 इंस्टीट्यूशंस. एंड एक्चुअली इन यूएस ऐसा है कि अगर इफ यू गेट सिलेक्टेड फॉर द पीएचडी, यू दे इनवाइट यू टू कम एंड विजिट बिफोर यू मेक योर
ओके
फाइनल डिसीजन. सो एंड इट्स लाइक ऑल एक्सपेंसेस पेड ट्रिप बेसिकली टू.
अमेजिंग
हाँ मतलब होनोलुलु और डीसी, तो मैं दोनों
बट
जगह
लुक्स
पे
लाइक
गया.
यू हैड योर
हाँ
आईज ऑन मैरीलैंड एंड यू गॉट इट ऑफ
हाँ
कोर्स
हाँ हाँ,
मतलब
मतलब आई
वो तो
हैड
था
लाइक मतलब I had my eyes
या
on Maryland, and मतलब वो हो गया था अच्छे से. And the thing is, I presented a good story to them as well. Like you have to present a good story. It's not just, you can't just say कि okay, I have good courses and good research experience, so give me the PhD position. It's not like that. So you have to present a good story. And my story was that I have a multidisciplinary background. Like I have a
Yeah.
background in engineering, like I have a background in mechanical engineering, I have a background in electrical engineering, and I have a background in astronomy. So when
Yeah.
you combine all those together, like you get such a diverse set of
तो 3 को लेने से अच्छा है मेरे को ही
skills.
ले लो.
मतलब it's
Like
like
that.
you present such a diverse set of skills that is very
Yes.
useful for like something like astronomical instrumentation. जैसे
Yes.
telescopes में you build instruments and so on.
Hmm.
And these are very cutting edge instruments that astronomers have to build because there are unique challenges in astronomy जो बाकी कहीं नहीं होते. तो
Right.
मतलब they need like और मेरा मेरा जो बैचलर्स का प्रोजेक्ट था, it was purely like I designed a payload and I launched it. मतलब like
Right.
what more is like, you know, what more do you want?
Right.
So
Right. Right.
so they you know, they understood, like, you know, the universities then understood कि हाँ मतलब there is a good opportunity with this person and will take that chance. So that's
Sure.
how,
Sure.
you know, that's how they took it. And मतलब क्योंकि
Cool.
बाद में जब मैं एक्चुअल में मेरीलैंड में गया तो मैंने अपने एडवाइजर से भी बात करी कि मतलब हाँ कैसे सिलेक्शन हुआ था. तो फिर उन्होंने ऐसे बोला था कि मतलब you had, you know, a good set of skills and you had good points in GRE and everything. तो मतलब
Cool.
GRE के मार्क्स भी मैटर करते हैं
बट
उस टाइम
बाकी
करते
भी
थे.
रेज्यूमे
हाँ,
मतलब पोर्टफोलियो बहुत सही था.
एग्जैक्टली हाँ.
Okay.
तो जीआरई मतलब मेरा कहने का ये मतलब है कि यू हैव टू वर्क ऑन, यू नो, मल्टीपल थिंग्स एंड इट्स नॉट जस्ट कि फाइनल ईयर में काम करके हो जाएगा. उससे पहले भी मतलब अगर
पहले
फाइनल
से
ईयर में
करना
हो
पड़ेगा.
और अभी सोच रहे हो तो अभी मतलब अभी लाइक मूविंग फॉरवर्ड यू डू ऑल द थिंग्स लाइक, यू नो, ट्राई टू गेट द रिकमेंडेशन लेटर्स, ट्राई टू गेट द स्टोरी, यू नो, योर स्टोरी राइट. मतलब जो भी हमने इससे पहले से किया है, ट्राई टू स्ट्रिंग दैट इन सच अ वे कि which विल बी अपीलिंग फॉर द पर्सन हु इज हायरिंग, लाइक फॉर द पर्सन हु इज सिलेक्टिंग. सो इट इज
राइट.
समथिंग लाइक दैट. मतलब ये जो चीज है तो अपनी पूरी स्टोरी को एक अच्छे तरीके से, मतलब अच्छे क्या कहूँ इसे, मतलब लाइक, यू नो, यू हैव टू पुट इट इन अ वेरी नाइस फॉर्मेट which will be appealing so that they can't say no to you.
राइट. द नेक्स्ट क्वेश्चन इज प्रदीप, हाउ डिड यू गेट एसोसिएटेड विद नासा? मतलब आपने तो बताया कि देर वेर लाइक अपॉर्चुनिटीज थ्रू मेरीलैंड. व्हेन डिड दैट हैपन, और फिर कौन सी अपॉर्चुनिटी मिली? एंड उसके बाद हमें ये भी जानना अच्छा लगेगा कि व्हाट इज नासा हबल फेलो.
राइट. तो एक्चुअली जब मैं मेरीलैंड में मेरा एक्सेप्टेंस हुआ था तो दे आल्सो गेव मी अ फेलोशिप अलोंग विद इट. तो उस दैट गेव मी लाइक द फेलो. सो देयर आर अ कपल ऑफ वेज इन व्हिच योर रिसर्च कैन गेट फंडेड. ईदर इट कैन बी अ फेलोशिप व्हिच मींस यू हैव फुल फ्रीडम ऑफ व्हाट यू वांट टू डू. एंड द सेकंड इज विथ लाइक रिसर्च असिस्टेंटशिप, जो एडवाइजर से आता है पैसा. तो एडवाइजर विल डिक्टेट लाइक, यू नो, दिस इज व्हाट यू शुड डू एंड दिस इज व्हाट you know, you should work on and so on. So you are basically like working you know, under the direction of that particular advisor. और तीसरा एक होता है जो टीचिंग एक्सपीरियंस, टीचिंग असिस्टेंटशिप होता है, जो
असिस्टेंटशिप.
टीचिंग वगैरह करके like that's how you get your money.
या.
But then even in that, like, you are, when you are working with an advisor, you have to like work with that. So thankfully, like, you know, when they selected me, they also selected me for the fellowship. So
Okay.
so I had a lot of research freedom कि मतलब मुझे किस चीज़ पे काम करना है. एंड मतलब एस्ट्रोनॉमी में, मतलब ये यूनिवर्सिटी ऑफ मेरीलैंड में ये तो था ही कि मतलब पहले से मुझे पता था कि उनका नासा गॉडर्ड के साथ देयर इज अ लॉट ऑफ कोलैबोरेशन because it's literally like, you know, 10 minutes by car. Like
कार.
it's very
अच्छा.
close, it's right there. And a lot of people, like a lot of grad students in Maryland work at NASA, and a lot of NASA scientists work with students in Maryland. So there was
मेरीलैंड.
already such a big sort of web
कोलैबोरेशन.
of relationship between the two. So that's how I, you know, then I sort of contacted the person who was responsible for, you know, for maintaining these kind of collaborations. So, and then, you know, he said, okay, there are these research opportunities going on right now and they're looking
Yeah.
for people. And so that's how I got, you know, that's how I got sort of absorbed into that NASA Goddard thing. So फिर मतलब एक
Yes.
बार, like, once you are in there, then it's like you know, then you just start working, then you start,
डिड
you
यू
know,
चूज अ
work
प्रोजेक्ट
hard.
कि वो नासा गॉडर्ड के साथ ही होगा? मतलब सिंस यू हैड अ फ्रीडम.
Not exactly in that sense. मतलब like I chose a project which I liked, and you
ओके.
know, then it just well, I mean, you
तो
know, you consider multiple factors, लेकिन I
सो इट
I
वाज नॉट द
I liked the
इंटेंशनल
project.
थिंग कि मुझे नासा के साथ जाना है, ऐसा नहीं है,
हाँ,
बट
मतलब
वो हो गया.
yeah, in a sense it was. And well, it's very hard to say क्योंकि ऐसा था कि, like, you know, when a certain project has multiple qualities, you can't say कि I picked it because of this quality. it had multiple qualities. So I
Okay.
chose the whole package. So
Of
like the
course.
project was
Yeah.
project had like some connection with NASA, and the project itself was so interesting. It was a it was a very like innovative kind of a project. So I worked
Hmm.
on something called photonics. So astronomy,
Hmm.
maybe photonics is just a completely different. Yes, actually, I have had like this kind of split interest throughout my career. जैसे मैं मैकेनिकल इंजीनियरिंग में था तो मैं
And
इलेक्ट्रिकल
astronomy.
और
Yeah.
एस्ट्रोनॉमी करता था, और जब मैं एस्ट्रोनॉमी में आया तब मैं फोटोनिक्स करने लगा. So photonics is like a completely different kind of a thing. Photonics is sort of like
Yeah.
electronics. जैसे electronic chips में you manipulate the flow of electrons on a chip. So in photonics, you
Hmm.
manipulate the flow of photons on a chip, and you can build very innovative instruments out of it. So in fact, I can show you I can show you one of my photonic chips just in a minute. But
Sure. Sure.
actually, you know what? Let me just do that right now. Give
Fine.
me
Fine.
just 1 second. So this is how they look like.
Wait. Let me hide.
Wait.
Okay. हाँ ये थे.
So
This is fine.
you see that shiny thing in the middle, that's a
Yes. Yes.
photonic
Yes.
chip. So that's actually a
Oh.
spectrograph that we can use for astronomical telescopes. It is so
अच्छा.
tiny. It is like, and nowadays we are building some of these chips which are like 2 grains of rice. It's like really
Right.
really tiny. Like they
Amazing.
are, yeah. So
Amazing.
and normally like the conventional astronomical instruments are the size of a room. Like you
Hmm.
can imagine
Yes.
from going from the size
True.
of a room to going
Hmm.
to the size of a chip. It's like जैसे सेमीकंडक्टर्स में जैसे रेवोल्यूशन हुआ था ना, वो 90s में,
Hmm.
वो 90s में भी नहीं, उससे पहले जैसे वैक्यूम ट्यूब्स
Yeah.
होती थी और उसके बाद लाइक सडनली इंटीग्रेटेड
Transistors आए हैं.
सर्किट्स. हाँ,
Hmm.
एग्जैक्टली, ट्रांजिस्टर्स आए, फिर इंटीग्रेटेड सर्किट्स आए, एंड एवरीथिंग बिकेम एक्सट्रीमली स्मॉल, एंड नाउ यू हैव like your phone has more computational power than the computers they used to launch like moon missions.
Right.
So your your like cell phone this tiny cell phone has so much power than like the whole room full of computers that they had back in 60s and 70s. So
Hmm.
it's sort of like that, like it's the current instruments in astronomy are very big, and we are now building something that is like a small chip that you can hold on your hand.
Okay.
So
So that's your project
it
basically.
was that was the main project that I worked on, and it was of
Hmm.
course very appealing. Matlab,
Okay.
it was very different, and I had a background in engineering, so I loved that as well, like that aspect as well. So it just
Hmm.
worked out, like all the chips fell in the right place, I would say.
Yeah. So you needed guidance from NASA, or did you like needed instruments or like material help from NASA? What was the
So
situation there?
matlab, so the thing is like there was, I mean, like a part of our team was at NASA.
Hmm.
So some of the instrument development was happening at NASA, and some of the instrument development was happening at Maryland. So
Hmm.
matlab, there was like a lot of overlap there, and like there was another research scientist that I was working with on science expert, like on like the science I would be doing. So it's my project wasn't just instrumentation. My project was
Hmm.
also what is the science that I will be doing, like what kind of astronomy I will be doing with it. So I
Hmm.
was going to study gamma ray bursts. So gamma ray
Acha.
bursts are like, it's like the second brightest thing after Big Bang, basically. It's like the second most destructive explosion after Big Bang. So
Acha.
it's like the brightest and the most powerful explosion in the universe.
Acha.
So जैसे supernova you might have heard of, like supernova happens when a star dies
Hmm.
and it explodes.
Yes.
So gamma ray burst is like supernova on steroids. So it is like thousand times
Okay.
brighter than a supernova. Um,
Oh, okay.
it's
Hmm.
1,000 times more powerful than a supernova. So it's like really, really, like for example, if a gamma ray burst happens in the Milky Way, and if it's pointed towards our solar system,
Earth.
if it's pointed towards Earth, then the life on
तो
Earth
गए
will
हम.
vanish. Life on Earth will vanish basically. So
अच्छा.
anywhere close to even if it happens in our galaxy, even if it's like 100,000 light years away, and if it's
Yeah.
pointed towards Earth, will be wiped out.
तो तुम लोग
So
वो
मतलब
डिटेक्ट कर रहे हो, मतलब वहां से निकलने वाला लाइट, मतलब लाइक यू जस्ट
right.
फाइंडिंग आउट
So
कहाँ कहाँ हो रहा है.
exactly. So we are looking at like gamma ray bursts that are happening like very early on in the, like in the life of the
बिग
universe.
बैंग,
So
बिग
they
बैंग के
say like,
पास.
not Big Bang ke pass, but like more towards like 7-8 billion years ago. Just the life of
Hmm.
the whole age of the universe is like 14 billion years, and so
या
we have been looking at gamma ray bursts that are like really
हाफ वे.
really far away, like like halfway through the
Hmm.
life of the universe. So it was,
Brilliant.
I mean, of course, that was a very interesting project that I would be using this instrumentation. I would be using this instrumentation for this science. So that was the
Yes.
connection, and the whole of that GRB science that happens thanks to this satellite that was launched by NASA Goddard. It's called the SWIFT satellite. So तो उसकी वो satellite का data, we use that satellite का data and many other data sets to do this kind of science. So all of that science component was happening at NASA Goddard. So that's
Acha.
how, so there was this kind of, the instrumentation, half of the instrumentation team was there, and also most of the science team was there at NASA Goddard. So
तो इसी
मतलब
वजह से वो हो गया.
मेरा बहुत ज़्यादा, like, I had a very close
Good
connection
relationship
that
with
way,
NASA.
and I worked there. Like I would go there. I had I had a place to work, and मतलब वो सब,
Yeah.
like it was and मतलब वो जो ऐसे नासा में एंटर करने के बाद ऐसे देखते हैं ना चीजें, तो ऐसे एकदम फील आती है. I don't know what to
Yeah.
say, but
Of course.
हाँ, मतलब it was a good experience. And
So
of course
NASA
they were
Hubble
building,
Fellowship, yeah.
and
Yeah.
just one thing, they were building
Sure, sure.
JWST at the time at NASA Goddard. तो जेम्स वेब स्पेस टेलीस्कोप जो है
अच्छा.
वो वहाँ पे
चल रहा था
क्लीन में
वहाँ पे.
बिल्ड हो रहा था तभी.
Oh,
So I could actually go and see it, like in person.
amazing.
So
Amazing,
like my
amazing.
WhatsApp pic जो that is
हाँ.
actually like the JWST in the
हाँ,
background. So
मला
it's
माहिती है. हाँ,
actually,
I know that. Yeah.
right, it's the real,
Yes.
like the real deal.
सही. Good. I would ask about NASA Hubble Fellowship now, and let me
Yeah.
just quickly go through the questions again.
Yeah.
वो आंसर करने की कोशिश करते हैं, क्योंकि मुझे तो बहुत इंटरेस्ट आ रहा है. पीपल फील कि यार ये तो हमारे साथ बातें नहीं कर रहे, थोड़ी बात कर लेते हैं.
Yes.
हेलो यार, हेलो एवरीवन. सॉरी यार, मतलब ये इतना सुनने लायक यार, इतना नॉलेज है मिलने लायक, तो इसलिए मैं सुन रहा हूँ और हम लोग सब सुन रहे हैं. वही पूछ रहा था कि एनवायरमेंटल इंजीनियरिंग का स्कोप क्या है, तो शॉर्ट में एकदम प्रदीप बता दो हाँ या ना में कितना अच्छा है जैसा है.
Yes. So actually, I have a friend who did his PhD in environmental engineering, and there is a lot of scope for environmental engineering. First is because the climate change is happening, and that's the biggest challenge that we are going to see for the next 50, 100 years. Basically, like from now to next whatever number of years, we are going to see that challenge, and it's an ever evolving challenge. So environmental engineering का obviously बहुत ज़्यादा मतलब impact है. So he, for example, worked on like renewable energy sources using certain type of like bacteria that he was sort of working on, but he was an environmental engineer. So matlab, even in environmental engineering, it's not just ki, like you are working with plants and animals and such. There is of course that, like you are working with that part, but he was also, you can also work on energy solutions. Like for example, what are the energy solutions that you can build which will be environmentally
and
more
I would add
sustainable and so on.
the sustainability development goals. So SDGs are there. तो कई सारी जगह पे SDGs पे काम चलता है. कई सारी फॉर्म्स, मतलब वो सिर्फ एनर्जी की कंपनी हो ऐसा भी नहीं है.
Exactly.
यू कैन जस्ट गूगल SDGs.
Right.
उसमें से कोई भी एक चीज ढूंढ लो, उसके लिए जो भी स्किल्स चाहिए वो भी सीख लो, एंड देन यू विल हैव मल्टीट्यूड ऑफ अपॉर्चुनिटीज. दैट्स व्हाट आई विल ऐड. I am from energy studies actually, so I have learned renewable energy.
Awesome.
So let's take another one. Somebody was asking about hello, Cupcake. The name is Cupcake. Okay, Cupcake is asking, hello sir, I want to do masters in applied mathematics. Would I have any scope in any space industry?
Right. So of course, like space industry
Shortly.
Space industry uses a lot of mathematics, and like all these calculations of like the aerodynamic like the aerodynamics, basically all the calculation of aerodynamics, astrodynamics, matlab jo orbital वगैरह के calculations होते हैं, and these are complicated calculations. It's not like it's not just Newton's laws and and then you are done. These are very complicated calculations which do require a lot of mathematical like applied mathematics, basically optimization उसमें लगता है, उसमें like solving these kind of doing mathematical modeling, doing numerical simulations and all of that. So space industry of course uses a lot of applied mathematics, so you certainly have a like a good amount of scope, and statistics of course, like the statistics, every single branch of science uses statistics, so you have ample opportunities.
Sure. Thank you so much for that answer. दोस्तों मैं सिर्फ रेलेवेंट सवाल ले रहा हूँ, बिकॉज हमें कवर बहुत कुछ करना है, एंड दिस लुक्स रियली इंटरेस्टिंग. अभी तो मैं बहुत सारी चीज़ें पूछने वाला हूँ. So this would be one of those last questions from the comments for now. Naveen is asking, engineers can do MSc Physics after engineering in IITs after clearing IIT JAM Physics. So there is an exam. So do you feel that this is a good way to switch to physics after getting a formal degree in physics?
Yes, so for जब मैंने बताया था ना कि मैं बैकअप भी कुछ ऑप्शंस लिए थे, so it was these. It was basically doing PhD in India.
Hello
So
Pradeep,
PhD.
I think your voice is cutting off.
Can
Everything's
you
all
hear it? Can you
everything's
hear it
all
again?
right?
Can you hear again?
I can hear
Can you
you,
hear
but
me?
it's
Okay.
cutting off. The quality is not as good as it was like before
Oh.
30 seconds.
Oh, well, that may be just a fluctuation, internet fluctuation.
हाँ
Not sure.
अब ठीक हो गया. अब ठीक हो
Okay,
गया. Yeah.
good. So yes, yes, engineering से PhD के लिए sorry, engineering से physics के switch करने के लिए I think JAM is a good exam. And you remember I just talked about like some backups that I had, like अगर मेरा like universities में selection नहीं होता तो so there is this another exam called JEST. So that's JEST. That's also this joint entrance for like science, like scientific institutions. तो वो भी एक एग्जाम होता है, तो उससे बहुत सारे इंस्टीट्यूशंस में एडमिशन लाइक फॉर फिजिक्स, फॉर एस्ट्रोनॉमी वगैरह जैसे बेसिक साइंसेस है उसके लिए मिल सकता है. सो देयर इज दैट एंड देयर इज आल्सो नेस्ट NEST. It's for there are some institutions in India like Center for Basic Sciences in Mumbai mein, and there is another institution in Kolkata. So there are like a few institutions in India, like these are very good institutions जहाँ पर you can get admission using these exams. So JEST है, NEST है, and even JAM, for example, you know, these are all good avenues और लोगों ने किया है इससे पहले, and they have had like, so for example, one of my friends, he was in energy science, वो IIT में ही था, वो उसने energy science में bachelor's और MTech भी कर लिया था. उसके बाद he made a switch to astronomy, and he did his PhD from IUCA, which is Inter University Center for Astronomy and Astrophysics. It's in Pune. It's world famous. So उसने वहां से किया, और वो basically exam के बाद उसने like he did JEST. उसके बाद he did it. So
very insightful, Pradeep. Very insightful. Thank you so much for that answer as well.
Yeah.
दोस्तों प्लीज कीप पुटिंग योर कमेंट्स, और जो भी लोग हैं लाइक कर दो वीडियो को, क्योंकि फिर ज़्यादा पहुंचेगा, यूट्यूब दिखाएगा आपने अपने एल्गोरिदम के हिसाब से, तो डू दैट, ज़्यादा लोगों तक नॉलेज पहुंचेगा. ठीक है, विल गेट बैक टू आवर क्वेश्चन आए. सो प्रदीप, NASA Hubble Fellowship, let's talk about that. What is the roadmap to it, and how did you get it? Like how tough is it? And जो भी है, मतलब I don't know anything. Just talk about it.
Sure. So NASA has this, there are some flagship fellowships that NASA has. So this is basically NASA's flagship fellowship, and the NASA's aim is to encourage, like the NASA's aim is to get the top quality talent for doing like whatever research that they think is the the best kind of like research that will define the directions in astronomy. So it's like they want to fund the research that will define like the next directions in astronomy. So that's why they select you there, Deva?
I'm here.
Okay, you are here. Okay, yeah. So they have these flagship fellowships, and so NASA Hubble Fellowship is the flagship fellowship in astronomy. So and it's a very competitive process, of course. Like you like all over the world, like like astronomy PhDs can apply to this fellowship, and they can come to US to work at a university of their choice using this fellowship. So so basically इसमें ऐसा होता है कि you have to write research proposals, you have to have a very good track record of research, and then मतलब of course recommendation letters is another component of it, and what is your research problem that you are tackling, and how is it relevant to the future of astronomy, and like what is your research background, and are you capable of pulling off that kind of a research, like these are the kind of metrics that they look at when they are doing this decision. So from all over the world, something like 480-ish एस्ट्रोनॉमी PhD के बाद के 3 सालों तक अप्लाई कर सकते हैं. सो PhD के बाद पोस्ट डॉक में भी हो तो भी अप्लाई कर सकते हैं.
And when did you get it?
Yes, so I also applied, and so from that 480 something people, they select 27 people from all over the world. and you basically, you have the choice कि मतलब कौन सी university में you want to do research, because you basically choose the university which would be best for doing that kind of a research. So मतलब that's how you go about it कि मतलब यहाँ मतलब like from all this pool of scientists they select like a small set of scientists and they give them full freedom कि मतलब पैसे भी देते like they give you the research, like they give you basically the fellowship covers all your salary and everything, and they give you research funds as well, and you have the choice to go to whichever university where you think you would be most productive, and then you do the research. मतलब independence basically, it's like you are not working under anyone or anything, you like lead your own research program, so that
amazing.
so that like something good comes out of it. So that's the whole philosophy of NASA Hubble Fellowship. So matlab, of course, like because it is so competitive, so it requires you to have like a good track record of research,
Right.
and you have to have good ideas in your mind, and those ideas need to be like very relevant for like the future of astronomy and so on. So matlab, of course, like there's again like a combination, and
मतलब वो 27 लोगों में तुम हो यार, बहुत क्या प्रोजेक्ट कर रहे हो यार तुम, मतलब लेडीज एंड जेंटलमैन, वी हैव शेल्डन कूपर इन द हाउस.
So matlab, so the project that I'm working on is actually again like a very split, it just reflects my split interest that I've always had throughout
Hey
my
Pradeep,
career.
let's wait.
Okay.
I think there was a bad connection. Let's wait for 10 seconds.
Sure.
I think you're frozen on the screen. You're laughing
no.
hysterically on the screen, but that looks nice.
Oh no.
Wait.
Okay.
Okay, so
Is it okay now?
I'm still waiting. पानी पी लेता हूँ मैं तब तक.
Sure. I'll also take a...
दोस्तों रुको, हम हबल फेलोशिप के बारे में जानते हैं. I think connection will be back soon. Unfortunately, I'm having a bad connection today. Maybe. It's fine now. I think it's fine now.
Okay. Good.
Go on. Yeah.
So so it I'm my research is still like a split, like it's split between my two interests. One is the photonics, which is like photonics is like the big next innovation in astronomy. So can you hear me, Deva, still?
Pradeep, let's wait again.
Okay.
I think it's still not.
Is it okay if I stop my camera for a moment?
Yeah, let's try that.
And talk. Okay.
Let's try.
Okay. So can you hear me now? Is it good?
Yeah, I can hear you, but it's still not up to the mark. I'd say let's wait again.
Because I can see you and hear you very well.
Maybe that's the problem from my side. Maybe let me just check. Hello, Pradeep, you there?
Yes, I'm there. Yeah.
अभी ठीक लग रहा है.
Okay.
अभी.
So
okay. Yeah.
Everything good?
Everything's good now. Let's see.
Perfect. So so like my research that I proposed, it was still like split interest that I've always worked on like throughout my career. जैसे मैंने बताया कि mechanical में था तो electrical में interest था, and like astronomy में I was doing photonics and astronomy both. So so I was spending like half of my time in the electrical engineering department there, like electrical and computer engineering department. तो मेरा एक ऑफिस वहाँ पे भी था और एक ऑफिस एस्ट्रोनॉमी में था, तो मैं ऐसे 50% टाइम स्पेंड करता था. तो photonics, like my research had one component, that was the photonics component. Ki, like I have already developed some of these chips, and I was going to develop even more innovative chips with my background. तो जैसे astronomy में spectrometers is something like you basically need to disperse the light at a very high resolution to be able to measure कि मतलब कि like इस star में like let's say this galaxy,
कौन सा component है, कितना absorb हुआ है,
exactly what is the composition of this galaxy, and how fast are the things moving in that galaxy. Like
luckily Pradeep, I am an instrumentation engineer, so I am able to understand the spectrometer.
Excellent. So matlab like a lot of people think like, spectrometer matlab aise like, you hold a prism and you get no, it's not like that. Matlab there is a lot more that goes behind it, and it's very revealing. Like it gives you a lot of information. You can see things moving basically using spectrometers. So that was one part of my proposal. I mean, of course, it was much more detailed than I'm saying right now, but that was like one part of proposal, to do like cutting edge instrumentation for developing these photonic instruments, like innovative photonic instruments, and not just for like looking at galaxies and such, but for looking at exoplanets, like planets on another planets in other in other solar systems. So like I these kind of instruments, these photonic instruments that I'm developing, are very relevant to that science basically. So and I don't know anyone who is not interested in exoplanets. I don't know anyone
even I've studied that thing. मतलब वो जो exoplanet find करने का, जैसे स्टार के सामने से जाएगा तो कितना लाइट कम होगा, वो चेक किया जाता है, वो पीरियड चेक किया जाता है, ऐसे कुछ, और उसके लिए जो इंस्ट्रूमेंट्स बन रहे हैं वो डिजाइन प्रदीप कर रहे हैं.
Yes, I mean I'm like one part of like the many.
I could understand and I could explain. That's a big thing for me.
Yes. So but and that's not the only way. There are many other ways to like study exoplanets, and they all require very high resolution spectroscopy, and it's really the cutting edge of, it's like the limit of what you can do basically, and you are trying to push the limits. So that's exactly what I proposed to do, and that's what I'm working on now. So that was the instrumentation part, that was the photonics part, and then there was the science part, which is basically looking at galaxies in the early universe and how they evolved. So that was an early universe. By early universe I mean like halfway through the age of the universe.
7 to 8 billion years ago.
Yes. 8 billion years
ago. I'm going to come to the very cool question for the podcast, and that is about wait let me go through that. एक तो क्वेश्चन है, व्हाट आर द करंट चैलेंजेस इन द फील्ड ऑफ एस्ट्रोनॉमी, वो एक चीज है. लेट्स आस्क दैट. सो यू आर वर्किंग ऑन इंस्ट्रूमेंटेशन, फिजिक्स, फोटोनिक्स एंड एवरीथिंग. सो लेट्स टॉक अबाउट व्हाट यू नो, ऑफ कोर्स, एंड यू नो सो मच. व्हाट डू यू थिंक आर द बिगेस्ट चैलेंजेस? यू वर टॉकिंग अबाउट कि बहुत ही अल्टीमेट चैलेंजेस होते हैं एस्ट्रोनॉमी में. सो ऑन टॉप ऑफ योर माइंड, व्हाट कैन यू थिंक ऑफ?
Right. So I'll say this, that astronomy uses like every single way to probe like galaxy, stars, everything, like, and by every single means it means all wavelengths, from gamma ray to X-ray to UV to optical to near infrared, microwave, radio, everything. Like we use every single wavelength, and we use neutrinos like particles and cosmic rays, and we use gravitational waves as well. Like मतलब electromagnetic waves तो हम use करते ही है, like we use the entire spectrum of electromagnetic waves, and we also cover we also look for gravitational waves, we also look for cosmic rays and everything. So it's a very broad kind of probes that we use for measuring different kinds of things. So ऐसे gravitational waves का तो मतलब लोगों ने सुना ही होगा कि gravitational waves is so amazing. It's so amazing. मतलब it's like you are trying to detect like deviations that are like a fraction of the size of a proton. Unbelievable. It is really unbelievable. मतलब ये ऐसा challenge है कि ऐसा challenge कहीं और है ही नहीं. मतलब like there is no other challenge like this. This is like the ultimate challenge in physics, ऐसे कह सकते हैं.
And they did that. And they detected that.
They detected that. And so that's how these gravitational waves were detected. So to detect gravitational waves, you require these extremely exquisite precision instruments that can detect, that can measure something like a deviation of the size of, that is fraction of the size of a proton. Like, you can imagine like अपना size क्या है, fraction मतलब proton
मतलब वो कितना बड़ा, मतलब सूरज जितना, अर्थ जितना बड़ा इंस्ट्रूमेंट यूज करना पड़ेगा उसके लिए?
No. So we use so there is something called interferometers that are used. So it is a 4 kilometer long, like it's like an L shape. So each of the arm of that interferometer is 4 kilometers basically. So it's like a 4 kilometer, and there are like it's basically like a Michelson interferometer जो ऐसे कभी engineering में वगैरह ऐसे कभी आया होगा across की, like Michelson interferometer. It's like when these mirrors, and there are these reflecting mirrors like in these interferometers, and they like even if they deflect slightly, you get some shift in the interference fringes, and that's what is measured. And of course, this is a very simplistic way of explaining it, but the challenge is enormous. मतलब you can imagine, the size of a proton का variation, 4 kilometer वाले arm में size of a proton का variation must be like ridiculous. So
yes, it's ridiculous.
to measure something like that, so that's a huge challenge, right? To measure something like, and the gravitational waves come from like mergers of black holes. Like दो black hole जब merge होते हैं, जो ऐसे दो black hole बहुत पास आते हैं, बहुत fast घूमते हैं, and then they merge. So like that's the
That's
kind
the
of
only
thing.
when you get that kind of deflection जो मतलब मेजर आप कर सकते हो शायद.
Right. So when exactly, like when these black holes merge, then they give out these gravitational waves, and like when Earth passes through those gravitational waves, that's when we can detect something like that. So it is an enormous challenge. So that is one.
Yes.
ये तो मतलब मैंने gravitational waves के बारे में बोला, which is like more like esoteric kind of a thing, but still very exciting. Now let me tell you something कि data science के related like कैसे challenges है. So for example, now just taking this cue from gravitational waves, तो जब ये gravitational waves के event होते हैं, जैसे black hole merge होते हैं, या neutron star जब merge होता है, तब ऐसे gravitational waves आते हैं, and something that we can now detect, like we मतलब वैसे 2017 में Nobel Prize was awarded for this, for like LIGO, laser interferometry gravitational wave observatory. So LIGO को was awarded the Nobel Prize in 2017.
So that was the first time people on Earth understood कि हाँ gravitational Earth और वो web
gravitational waves है, gravitational waves. Right. Like it was the conclusive proof that gravitational waves exist. That came in 2015 और फिर 2017 में Nobel Prize मिला था. So now just taking a cue from there, तो जैसे ये जो न्यूट्रॉन स्टार मर्ज होते हैं, तो दैट आल्सो गिव्स आउट अ वेरी एक्सट्रीमली ल्यूमिनस burst. It's called that is also called a gamma ray burst. मतलब gamma ray burst में भी दो classes होते हैं. So this class of gamma ray burst these are basically short gamma ray burst, क्योंकि उसमें बहुत short duration के लिए वो burst होता है. So now what you can do is, once you detected these gravitational waves, you can actually just detect them, but you cannot localize them कि sky में कहाँ पर हुआ, मतलब किस direction से आई है gravitational waves, ये नहीं बता सकते. तो ये पताना बहुत difficult होता है. Even if you detected the gravitational waves, it's very hard to say कि हाँ इस particular object से आया. It's very difficult to say that. So for that you need electromagnetic waves. तो ये जब ऐसे न्यूट्रॉन स्टार मर्ज होते हैं, तो दे गिव आउट इलेक्ट्रोमैग्नेटिक वेव्स, तो एंड दे आल्सो गिव आउट ग्रेविटेशनल वेव्स. तो ग्रेविटेशनल वेव्स से भी डिटेक्शन हो सकता है और इलेक्ट्रोमैग्नेटिक से भी डिटेक्शन हो सकता है. सो इन 2017 देयर वाज वन सच इवेंट. मतलब आज तक एक ही बार ऐसा इवेंट हुआ है जिसमें ग्रेविटेशनल वेव्स भी डिटेक्ट हुए और इलेक्ट्रोमैग्नेटिक वेव्स भी डिटेक्ट हुए. हाँ, मतलब न्यूट्रिनोस नहीं, बट इलेक्ट्रोमैग्नेटिक वेव्स जैसे गैमा रेज, एक्स रेज वगैरह, ये सब भी डिटेक्ट हुए. और ये भी बहुत डिफिकल्ट चैलेंज है, क्योंकि like once let's say you detect everything, but you detected the gravitational waves, but you need to find out कि मतलब sky में कहाँ से हुआ. तो sky is so big and searching every nook and corner of that particular sky कि इतने बड़े एरिया से कहीं से तो भी हुआ है. Like like this hemisphere, इस hemisphere में कहीं तो भी हुआ है. Right. Now you start how would you start searching something like that, and these bursts go away very quickly, like in 2 days they will be gone.
अच्छा, मतलब 2 दिन तक रहेगा, मतलब डिटेक्ट हुआ तो 2 दिन तक दिख सकता है.
2 दिन तक होगा. हाँ, एग्जैक्टली 2 दिन तक रहेगा, और फिर उसके बाद एंड इट्स एक्सट्रीमली फेंट एनीवे. सो मतलब you need massive telescopes to look at this, and you can't scan like the entire sky with such massive telescopes. So you can only scan like small parts of the sky in one day. And मतलब इतने बड़े स्काई में अगर पूरा सर्च करना है, इट्स रियली डिफिकल्ट चैलेंज. तो इट्स अ डेटा साइंस चैलेंज एज वेल, क्योंकि इसमें ऐसा होता है कि देयर आर स्मॉलर टेलीस्कोप्स व्हिच स्कैन द होल स्काई, and then उनसे इतनी सारी images, like gigabytes and gigabytes of data comes in, and we do machine learning to basically rule out a lot of artifacts and such, and then we come down from like millions of candidates to like thousands of candidates, और फिर वो thousands में भी हम लोग फिर human vetting भी करते हैं. And then so it's basically like a data science challenge as well. So to go from millions of objects to like 1,000 in just a matter of a few hours, and then going from there to actually that one candidate, मतलब million से भी one ही, there is only one which is like the actual thing, right? So इसमें million से भी like going from that million to that one, it's really it's an enormous challenge, and doing that in a short span of like just one day or so, because 2 दिन में वो वैसे भी चला जाएगा. So like
Yeah.
doing that in just a span of one day, it's an enormous challenge and takes a global effort. मतलब there is
Global
something called,
team and effort, right?
it takes a global team. मतलब यहाँ पे टीम है, Caltech में टीम है, there is a team in Maryland, there are teams in Israel, there are teams in India, there are teams in Japan. So like we are working, and there are teams in Europe, so we are all working together to do something like this. So मतलब it is an
Brilliant.
enormous like data science challenge. And of course exoplanets is another challenge कि मतलब like, so detecting the motion. So this is just last challenge that I will talk about.
Sure. Yeah.
Such so exciting challenge.
Yeah.
So, and this is something that I'm really working on right now. So the gravitational waves thing, I worked on that as like during my undergrad. So not undergrad, during my PhD. So like a part of my research, this was sort of like a side project for me. So like a part of my research was on that gravitational wave follow-up thing as well. But this is something that I'm working on right now. Is the exoplanet, like you are trying to measure the velocities of the exoplanets, you're trying to measure the masses of the exoplanets. And how do you do that? So let's say you have this star and the planet is going around it, but what happens is that the star also moves, like wobbles a little bit when the planet goes around it, because it's also moving around the center of mass, right? So the star also wobbles, but it wobbles very low. Like for example, sun or earth hai. Let's say if there is a sun and earth, earth is going around sun at like 30 kilometers per second. But sun is only moving at the speed of 10 centimeters per second, because earth का mass तो बहुत कम है as compared to sun. So the sun का wobble जो है, that is only 10 centimeters per second. You imagine we walk faster than that, like 10 centimeters. Like that's the slow. That is how slow it moves. That is how slow.
और वो detect करना इतने दूर से.
Exactly. Now you want to detect that from like tens of light years away.
Yeah.
I mean, sun तो यहीं पे है, but like sun is only 8 light minutes away, and now you imagine detecting something like that from tens of light years away. It is an enormous challenge detecting something like that, and it takes exquisite precision. मतलब इतना precision लगता है कि मतलब जैसे like when we achieve that kind of a precision, there will be a Nobel Prize coming. Basically.
Unbelievable.
So it is exquisite precision that is required for measuring wobbles like this.
You are working on this.
I'm working on one component of it for sure.
Brilliant, man.
And of course, there are many other people in the world who are, who are
All
like
the very
pouring
best,
all
yeah.
their lives on this particular challenge. So
मुझे इसमें I have a question on this. मतलब सोलर सिस्टम में जैसे वॉबल सन को वॉबल तो हर प्लैनेट करेगा.
right.
How like इतने दूर से हमें अगर
right.
how do we know कि इसी प्लैनेट की वजह से वॉबल हो रहा है या फिर
very good question. So the thing is, the wobble also happens with that frequency, right? Earth moves around the sun over in 1 year, right? So तो जो sun का wobble earth की वजह से होगा, वो sinusoid 1 year वाला होगा. और जो sun का wobble Jupiter की वजह से होता है, so जो Jupiter goes around the sun in 12 years. So जो sun का wobble जो Jupiter की वजह से होगा, वो उसका period 12 years रहेगा. So that's how you can measure the that kind
थोड़ा
of
मतलब frequency filtering हो जाएगा तो मतलब
exactly
FFT निकाल लोगे तो समझ जाएगा, ठीक है.
Exactly. So it is something like that, and the challenge is so enormous, I'll say, कि the kind of deflection that you are measuring on the detector is like 5 silicon atoms. Like it's like you are measuring, it's like this big detector, and on that you are measuring the deflection of 5 silicon atoms. That's like 5 nanometers. That kind of a deflection that you are measuring on your CCD, on your like the detector. So it is like, it's just an insane kind of a challenge that we have in astronomy. So there are
इसमें
like
तो यार मतलब कोई भी नॉर्मल सा नॉइज भी इतना मतलब छोटा सा मैग्नीट्यूड क्रिएट करके छोड़ देगा. हाँ.
So the kind of temperature stability that is required is like fraction of a millikelvin. It's like a fraction of a millikelvin kind of a temperature stability that is required, and the mechanical stability that is required is again like like nanometer scale mechanical precision, like nanometer scale mechanical stability is required, and that's why we are building these chips. So these chips, क्योंकि अगर बहुत बड़ा इंस्ट्रूमेंट होगा, जैसे रूम के साइज का इंस्ट्रूमेंट होगा, तो तब तो कुछ भी यहाँ पे कुछ भी हुआ, लाइक थोड़ा सा वाइब्रेशन हुआ, तो it will go out of its tuning. लेकिन if it's on such a small chip, then you can actually stabilize that chip really well, like stabilize that chip to like whatever temperature precision that you require, whatever mechanical precision that you require, you can do that. So that's why this thing is very interesting. So
unbelievable, Pradeep. This is so cool. and my wife commented, "Yo, this is going in the awesome direction." She's so happy. Like, see, I have two choices, Pradeep. I really want to ask, और मेरे viewers को भी मैं पूछ रहा हूँ. There are two choices. Pradeep can share about his career path, or Pradeep can, मतलब इस अभी जो time बचा, we already covered like 1 in 0.25 hours जो भी है. We can ask him about the universe, challenges, galaxies, cool projects, science, या फिर we can talk about what is left कि आपके आजू बाजू में ये इंजीनियर्स है क्या, वो इंजीनियर्स है क्या, मतलब करियर रिलेटेड कि हाँ आप कहाँ कैसे पहुँच सकते हो. वी ऑलरेडी कवर्ड अ लॉट. आई वुड लाइक टू नो फ्रॉम whoever is watching, 10 लोग जो देख रहे हैं, प्लीज़ मुझे एक बार रिप्लाई करके बोल दो कि कौन से डायरेक्शन में आपको जाना है. आपको ये अभी हम जो चल रहा है प्रोजेक्ट्स के बारे में, जो एक्चुअल चैलेंजेस अभी बात कर रहे हैं, आई वुड रियली लाइक टू नो दैट. या फिर मैं प्रदीप को बाद में भी बुला सकता हूँ इफ ही गेट्स टाइम, मतलब हिज टाइम इज सो इम्पोर्टेंट. आई हैव फ्यू. ओके, सो प्रसादी सिंह करियर के बारे में बात करते हैं, मतलब करियर डायरेक्शन के. सो कूल, थैंक यू फॉर योर इनपुट. आई विल गो विथ योर, एक दो लोग बता दो लास्ट दैट, क्योंकि ज़्यादा मतलब जो क्वेश्चंस है इट रिलेट्स टू हाउ यू मूव टू एवरीथिंग एल्स. बाकी तो जैसे करियर के बारे में काफ़ी बात कर ली है, बट फाइन.
So
sure.
Yeah, so Deva, do you want to talk about like more about the undergrad thing that people should do? Because I think a lot of people might be like in that phase कि मतलब बहुत सारे जो मुझे भी questions आते हैं लोगों के, तो वो ऐसे आते हैं like जब like they are in undergrad and they want to do something good with their life, and what should they do in their undergrad? I think that's like one.
Well, you know what? You really talked really briefly about that. What I would suggest is you can seek back the video and watch that part. You'll get a very good insight. And frankly, I have designed this questionnaire as per the career aspect of it.
Right.
I would really, मतलब मैंने बाकी add-on questions तो डाले ही थे जिसका volume कम है, which I am feeling right now, और जिसके लिए time हमें शायद बाद में निकालना पड़ेगा शायद. But yes, we'll talk about what is there in the questionnaire. And Pradeep, actually our viewership includes masters level students. So they might want to switch their careers into PhD. तो शायद वो PhD करते हुए अगर वो किसी को जाना है एस्ट्रोनॉमी में तब जाएंगे. So let's talk about all the other stuff that's remaining.
Sure.
What I would like to know, Pradeep, if we talk about the career, like the diverse set of people that you encounter, what backgrounds your colleagues have. Can anyone aspire to be an astronomer? Like, is there any bar कि ये नहीं बन सकता, वो नहीं बन सकता?
So yeah, I'll say कि specific astronomy में तो सब कुछ use होता है. Like as I said, like we go from gamma rays all the way to radio, and we do like like gravitational waves and such. So मतलब you can imagine कि gravitational waves जैसा exciting and like really like ऐसा problem दुनिया में और कोई है ही नहीं. Like if you want to solve like such a unique problem and such a challenging problem that requires a whole bunch of different kind of expertise. Like उसमें electrical engineers लगते हैं, उसमें optics के मतलब जो experts है वो लगते हैं, उसमें quantum like physicists and those who know quantum mechanics like quantum dynamics really well. You need those. You need mathematicians. You need engineers who can build something like this. So it takes a whole variety of people to be able to do something like that.
Yeah.
And I'm not saying just from the perspective of engineering, but also like just astronomy mein, there are many paths. Like there are many ways that how you can connect yourself to astronomy. So there is astronomical outreach hota hai. Jaise like a lot of people are very good at communicating, and they want to be like communicators. Like they want to be like jaise there are like in the US, I'll say there are many people who specialized in science communication and like astronomy communication and so on. So they build whole their careers based on just that. And then there are other people who are in the field of like arts and animations and such, and they build so जैसे अभी कोई नासा का वीडियो वगैरह देखा होगा, JWST वगैरह का देखा होगा लॉन्च, या उसमें ऐसे दिखाते होंगे ना ऐसे like this is how JWST will be launched, this is how it will open and this is how it moves, and ये सब कैसे बनता है, ये सब एनिमेटर्स बनाते हैं ना. सो दीज एनिमेटर्स दे हैव सम नॉलेज ऑफ एस्ट्रोनॉमी एंड दे हैव a lot of knowledge of animation, and so that's how they make something like that. And you might have seen all kinds of videos कि मतलब हाँ ऐसे planet है, like you might have seen renderings of planets and such. तो ये सब कैसे बनता है? So there are these artists that that have some background of astronomy and a lot of background about their art. So not just engineers but also artists and educators and these communicators can get into the field of astronomy. Specifically from the field of engineering, agar मैं कहूँ, so we get all kinds of, like we work with all kinds of people, like we work with system engineers for example. जैसे अभी इतने बड़े बड़े projects है, जेम्स वेब स्पेस टेलीस्कोप वगैरह है, इसमें there are thousands of people who are working and there are so many subsystems, right? Space के किसी भी project में there are so many subsystems, right? And so you need something like a system engineer who can bring everything together, who can do the project management and so on. So वो भी मतलब हमारे इसमें लगता है. And we of course need electrical engineers and mechanical engineers and even civil engineers. जैसे ये इतने बड़े बड़े telescopes build होते हैं, so those telescopes, they get built on, like you can't have like
On
a
the
shaky
ground.
telescope, right? They get built on the ground, and a lot of times they are, I mean, most of these telescopes are at the top of the mountains, and as you know, the top of the mountains are very geologically active, कि earthquake होते रहते हैं. So you have to build something that is really, really strong and something that will not vibrate as much, right? Because if there is such a big telescope and it is vibrating all the time, then your star will just keep moving. मतलब अपने image में,
Yes.
like it won't remain steady. You don't want something like that, right? You want something that is exquisitely stable, right? मतलब हमने इंस्ट्रूमेंट वगैरह तो बिल्ड कर लिया एकदम नैनोमीटर प्रिसिजन का, और यहाँ पे टेलीस्कोप ही मूव हो रहा है, तब तो मतलब कोई फायदा ही नहीं है ना. सो यू वांट द टेलीस्कोप टू बी रियली स्टेबल, राइट? सो एंड दैट इज द सिविल इंजीनियरिंग चैलेंज. सो it requires all. So in fact, one of my summer internship projects that I did in Nainital, there is an institute. It's called Aryabhatta Research Institute for observational sciences. So ARIES करके नाम है उसका. It's at the mountain top in Nainital.
अच्छा.
So वहाँ पे actually they were building the biggest telescope in India and also the Asia's biggest telescope. It was a 3.6 meter telescope. It's near Nainital. तो वहाँ पे they were building, and my project was to measure the stability of the structure. मतलब तब वो actually जब वो build हो रहा था ना, तो like we only had the foundation by that time. Like तभी बस उसका foundation build हुआ था. तो मुझे उसकी structural stability measure, मतलब like I created a device that would measure structural stability of a structure like that. Because it's a very unique kind of a structure. It's not the kind of structure that you see in every other building. So it's a very unique kind of a structure. So and very unique kind of material. So you want to measure the structural stability of that kind of a thing. So I built an instrument which would measure just that. So I turned that into a paper, and that paper got published in a civil engineering journal. So you can imagine, it was a civil engineering journal, and I was doing mechanical engineering, and it was all related to astronomy. So it's a complete hodgepodge. So you can think about, like, we work with all kinds of people, right? We work with civil engineers, we work with electrical engineers, mechanical engineers. So there is a lot of variety that is happening there, and definitely like electrical engineers तो मतलब हर जगह use होते हैं, because if you are sending something in space, then you have to do all kinds of management there. Like there is a power that is like, everything is limited. Power is limited, size is limited, weight is limited, and in that limit you have to do exquisite measurements. So matlab, there is like, it's of course an instrumentation challenge. It's an electrical engineering challenge, mechanical engineering challenge. So it's a very challenging thing. Like, you want to build something like a James Webb Space Telescope. It requires like innovative mind to be able to do something like that. There is nothing like that exists in the world at all, right? So it's all first time, just a first time ho raha hai. And so that you need a lot of expertise there.
Well, clearly, Pradeep, I underestimated the volume that could have been covered in whatever time that we had. Seriously, I had to skip a lot of questions. But you know what? I am so happy listening to like whatever that you had to share. मतलब we already have covered a lot of time.
Right.
So see, what I would like to do is to arrange one more podcast someday, whenever time permits, if of course you are available. I don't want to take a lot of your time, but then we can only discuss about the coolest and like weirdest things in space and everything, of course, which you have to share. And for now, I'd like to ask that one question lastly, one of such questions. जो भी लोग ये करियर पाथ के बारे में पूछना चाह रहे हैं and which are commenting right now, so what I'd request them, we have covered a lot of stuff. वीडियो के पहले उसी के लिए वीडियो है एक्चुअली. देयर वर सम एड ऑन क्वेश्चंस की जो हमें लगा कि could inspire you to work in astronomy. So there are some questions which I'm not covering all. I probably will design more and will request Pradeep जब भी है. But you can seek back and watch those. Pradeep, one very important question और जो मैं last लूँगा. We are putting so much energy, so much time, so much effort, so much money in solving so many problems that exist in space, and we don't even know what is the volume of the problems that
Right.
are unknown to us, right? Where is this going? Why are we doing this? And why astronomy is so important in your
Right.
perspective?
Right. I think that's a very good question, and it's a kind of a question that I guess get asked a lot. So, matlab, see, the one thing is, as human beings, we are like, the most fundamental kind of curiosities that we have. Matlab, ye religion, vagera, like, the spirituality and all of that. Like, why do you think all these things come up in our lives? It's just because we have some very fundamental questions ingrained in our biology. Like, we have these questions, like, where did we come from? Like, and like, are there other creatures like us somewhere else? Like, you look up in the sky and you start wondering about, like, just do this one experiment. Pick a remote spot anywhere close to you, go there and just lie down and look at the sky for like several hours, and you will see like all these questions coming up in your mind ki matlab, like, where where did we all come from? Like, how did the life come on earth? Where did the earth come from? And like, where did all these stars come from? And why, like, where are we going with this? Like, where are we, like, what is the next thing that is going to happen with the humanity or with the earth? And what is the are there other creatures like us who may be looking at us and they may be wondering about the same questions? So these are all very fundamental questions that are very much ingrained in our biology. मतलब कोई 5-6 साल का बच्चा भी होगा ना, तो भी उसे भी ऐसा लगता है कि हाँ, मतलब कुछ एलियंस वगैरह हो गए, कुछ अलग, मतलब कहीं और पे ऐसे कहीं और अलग टाइप के दिखने वाले एलियन, मतलब उनका ड्राइंग कंपटीशन कर दो तो यू विल गेट
I'm that
100
kid.
टाइप्स ऑफ एलियंस, राइट?
I'm that kid, yeah. Yes.
So like, you get these 100 kinds of different imaginations. So this is ingrained in our mind. So this kind of pursuit of, like, where did we come from, like this pursuit of history of the cosmos, like universe kahan se paida hua, or like how did the universe evolve to a point where we can actually come to existence? Because you can imagine, पहले यूनिवर्स में सिर्फ हाइड्रोजन और हीलियम ही था, and then we came, like, ultimately after billions of years we came. So you can imagine कि how did something like that happens, कि सिर्फ पहले यूनिवर्स में हाइड्रोजन और हीलियम ही था, there was nothing else, and then this complex structures, like, and we have like like eyes, ears and everything, like, and we can talk and we can think about things, like, hydrogen and helium cannot think about themselves, right?
Yeah.
But we can, like, how did we come from? And we came from that hydrogen and helium, मतलब वो हाइड्रोजन हीलियम के स्टार्स बने, फिर वो स्टार्स से सारे एलिमेंट्स बने, फिर एलिमेंट्स से हम बने, है ना? So I mean, this is such a fascinating pursuit in itself, कि मतलब इसका, like, it's a fascinating pursuit just because of the curiosity of the human mind. So that is one part, कि मतलब, like, just the curiosity of the human mind, that is one. And the second thing is the technologies that we build to solve these kind of questions. Like, for example, exoplanets, like, is there a possibility of a life somewhere else in the universe, like somewhere on another star, like another like somewhere on another planet, or in other bodies in the solar, on, like, is there a possibility of life on other bodies in the solar system? So we send probes on Mars, we send probes on
Venus.
like, to the satellites of Jupiter, for example. Now there is going to be a mission called Europa mission. So Europa mission is actually going to land on the surface of Europa, and it's going to do a lot of explorations there, because Europa is, like, one of the biggest contenders for life in the solar system. And
in the solar system, yeah.
I'm not saying just conditions for life, but actual life, possibility of an actual
Existing.
life, like actual organism, like, kind of a life on solar
Really?
system. There is a possibility. So we want to go and we want to check, like, so for example, like, that it's like, you are in a desert and there is a rock in front of you. You want to turn that rock and see what is underneath it. So it's just, it's just like that. Like, we know that there is life supporting, we know that there is life supporting conditions on Europa. You cannot help but, and if you have the capability to go there, you cannot help but go there. Like, you have to go there and you have to see, like, matlab, like in like what mind you would like you should be in a very wrong state of mind if you are thinking कि हाँ नहीं कुछ भी explore करने की जरूरत नहीं यहाँ पे यही पे सब like that's a very wrong state of mind.
Okay.
Like if you know that there could be
I
life
get.
somewhere else, you want to know,
Yeah.
and when that discovery is made, you can imagine कि world will change. Like that
Yes.
when the
I get
discovery
it.
is made, like that there is life somewhere else other than Earth,
Hmm.
that would be such an earth-shattering discovery, right? So I
Yes.
mean, it's just, so there is that curiosity as well. Like this, there is life like somewhere else. Like एक तो curiosity ये है कि कहाँ से हम लोग आए हैं, and like how did everything come together. And the second thing is there life? If are there creatures like us somewhere else in the solar system, somewhere else on other planets? So it's a pursuit कि मतलब you can't help but do it. Like you have to do it. That kind of a pursuit. And astronomy takes a very small fraction of the GDP and everything. So it's this we only ask for small amount of money. So it's not like we are taking like the whole budget and
Yes.
of science or anything. We are it's a small kind of investment for doing
Yes.
such a big such a
Big
big
challenge. Yeah.
big picture.
Hmm.
Exactly, right? So religion vagera, like religion, every religion has some story about how everything came to. And because
Yes.
why does every religion have that story? It's because we have that question in our mind. That's why religion
Exactly. Exactly.
has to
Beautifully.
come up with some
Beautifully
answer,
said. Beautifully said.
right?
Yes.
Right. So
Yeah.
why does every religion have some story about how did the life come about and
Yes.
so on? Like because these are the questions, these
वो
are
हर कोई
ingrained
पूछता है और
questions in our
उसको
mind.
जवाब देना होता है और इस वजह से वो
Exactly.
एक टेम्पलेट है हर किसी के लिए कि हाँ ऐसे ऐसे
Exactly.
हुआ.
Exactly,
Yeah,
right?
fine.
And so we are answering these questions with science. Like we are going and looking for things, and we are finding conditions that are suitable, and we are finding like कि कौन सी conditions होते हैं कि जिससे life evolve होते हैं, and so on. So these are the pursuits की मतलब वो ऐसे intellectual अपने human mind की उपज ही है. मतलब like it has to happen. Like you can't
Yes.
just shove them under the rug. You have to explore them. So
True.
that is that. And now the third thing that I would talk is
Hmm.
the technologies that we build in astronomy that actually is very helpful in real life as well, like on our very earthly pursuits as well. So
Yeah.
just say for example, I am working on this photonics thing, right? Like I'm working on this photonic chips and such for doing spectroscopy. Now imagine a problem very similar to astronomy. We have a similar problem in biophotonics as well. So
Hmm.
the work that I work on, it's called astrophotonics. This is as
Hmm.
photonics applied in astronomy, it's called astrophotonics. But the thing that we are developing in astronomy, it is very useful for biophotonics, for measuring, like for detecting cancer in tissues, for
Oh,
detecting
okay.
defects in the retina. So there is something called
Hmm.
optical coherence tomography, and these
Hmm.
kind of chips, these are used in doing optical coherence tomography of the retina to
Hmm.
image the retina in 3D. तो जैसे
Hmm.
अलग अलग वेवलेंथ्स जो होते हैं लाइट के, अलग अलग वेवलेंथ्स, दे प्रोब डिफरेंट लेयर्स ऑफ कोरोना, सो
Hmm.
डिफरेंट लेयर्स ऑफ रेटिना. सो
Okay.
ये अलग अलग रेटिना की लेवल्स देखने के लिए दे यूज ऑप्टिकल कोहेरेंस टोमोग्राफी, और ऑप्टिकल कोहेरेंस टोमोग्राफी में ऐसी चिप्स यूज होती हैं. So and these kind of chips, like the kind of challenges that we are trying to solve, and the kind of, just say, like we want everything high efficiency, we have
Hmm.
very low amount of light, we want to do imaging and spectroscopy at the same time. जैसे
Right.
like for example retina के इसमें देखा जाए तो you are it's not like you are just taking the spectrum of just one point. You want to image the whole retina, and you want to take the spectroscopy of every single point. So
Right.
how can we do that? So there is this thing from astronomy has come to biology. Like
Come to help. Hmm.
there's a concept called integral field spectroscopy. So integral field spectroscopy is basically when you do imaging and spectroscopy at the same time. So like for example, you are taking image of, let's say you have a spinach, you are taking
Hmm.
image of that spinach, but you are also doing spectroscopy of the whole spinach, so you can see which chemicals are at which location.
Hmm. Hmm.
So that is
Okay.
something that is very useful in biology, biomedical, like for cancer detection, for like a lot of different pursuits. It is also
Right.
useful for earth sciences ki jaise earth satellites hai, when they are looking
Hmm.
down, they are looking at, like different structures, and they want to find out ki yahan pe kaun se chemicals, like what are the, like
Hmm.
what is the
Hidden
temperature at
hidden
this
under
location.
the ground. Yeah.
Exactly. Yeah.
Hmm.
So like you want to measure, like what is the composition deep under the ocean.
Hmm.
Now you can't use optical light for that, you have to use infrared light for that. So and infrared,
Right.
you have to do spectroscopy to be able to find out ki, matlab, like what is the composition, what is the temperature. And it's
Hmm.
not just spectroscopy, but you have to do imaging and spectroscopy together. And so
Right.
these are the kind of things that are useful for
Hmm.
doing pursuits that are very very much like connected to our life. So it's
True.
not, so there is a lot of क्या कहूँ मैं, there is a lot of
Utility in working in astronomy,
right,
of
there
course.
is a lot of utility and
Hmm.
spin-offs, like there are so many spin-offs of astronomy,
Hmm.
whether like this imaging and optics and all of that I said, that is one spin-off of astronomy. There are other, like there are discoveries in physics that have been made which now are useful to us, like for example GPS वगैरह. So
Hmm.
GPS, like you know people could have thought about the same things 100 years ago, जब
Hmm.
like Einstein's theory of relativity came in, because the relativity only solved like very small problem कि हाँ मतलब मर्क्यूरी का ऑर्बिट ऐसा इतना छोटे से इससे क्यों डिविएट होता है, like it's an esoteric pursuit, मतलब like who
Okay.
cares about Mercury's orbit on Earth, right? But because of that relativity was discovered, because of the
Yes.
relativity now we have this GPS which gives us
Hmm.
very precise time and which runs everything around us, like मतलब
Hmm.
जो भी मतलब टाइमिंग रिलेटेड चीजें हैं, जैसे टाइमिंग जिसमें जिसमें भी टाइमिंग का यूज होता है, like there are many,
Hmm.
like all these communication satellites and all these like GPS satellites and everything, it requires exquisite timing, and that
Yes.
exquisite timing is only possible because we know about relativity. So
Awesome.
there are all of these connections which you cannot imagine कि मतलब ये
Hmm.
सब डेवलप करने के बाद होगा क्या, मतलब and it's like you, like to solve such, first of all the problems themselves are very interesting.
Hmm.
Second is we are ingrained, like our brain is ingrained in exploring such kind of new worlds. And
Hmm.
the third is like the technologies that you are developing for probing these new worlds, these you just cannot imagine what is their impact on real life as well, क्योंकि
Hmm.
ये सारी जो
बट वो है,
टेक्नोलॉजी हम
इमेजिन
build
नहीं
कर
कर
रहे
पा
हैं,
रहे, लेकिन देयर इज अ लॉट
exactly
ऑफ
वो
यूटिलिटी देयर, या.
है जो, so like all the kinds of photonic instruments that we are working on, these are
Hmm.
directly useful for biology, they are useful for telecom as well. So ये AWG, like these kind of chips that we are building, the idea actually has come from telecommunication industry. So all this high
Hmm.
speed internet, मतलब हम लोग अभी जिस high speed internet पे काम कर रहे हैं ना, so that internet is passing through one of these chips right now.
Beautiful.
Yeah,
Hmm.
yeah. So that idea, this idea that we are working on, that came from telecommunication, and now whatever improvements and whatever innovations that we are doing in astronomy, those are useful for the telecommunication industry. So मतलब हम लोगों का back and forth चल रहा है. So
Right. And
and
that's a mic drop, bro.
right, yeah, I mean that's such a
Yes.
it's a pursuit, I would say it's one of
Yes.
the most noble pursuits
I would say so, yeah.
in science. So I'm all for it, मतलब astronomy तो करना ही
I'm so
मतलब एक
fascinated
बनता
with
ही है.
this, and of course, I would like to ask for the viewers, जो भी लोग देख रहे हैं, प्लीज आपका कंसेंट दो या फिर आपकी आपकी थॉट प्रोसेस दो. क्या आप प्रदीप को फिर से पॉडकास्ट में देखना चाहोगे, वेयर वी डिस्कस और द अदर थिंग्स दैन करियर, what he knows, जो भी है. There are so many things that we can ask Pradeep. He has worked on so many things, और जो कि मैं पूछ भी नहीं पाया. मतलब there were so many cool things, जैसे टेलीस्कोप टाइम हो गया, या फिर प्रोजेक्ट्स दैट ही हैज डन इन हिज बीटेक, जो भी है. करियर के बारे में तो उन्होंने बोला. Everybody who is asking about how they can shape their career into astronomy, जो भी मैंने प्रदीप से सीखा अभी 1 घंटे में, मैं आपको ये बता सकता हूँ कि स्टार्टिंग से अगर आप आपके प्रोजेक्ट्स इस तरह करोगे जिसमें कुछ एस्ट्रोनॉमी का प्रॉब्लम सॉल्व करने की आप कोशिश कर रहे हो आपके हिसाब से, बीट इन योर फील्ड, ट्राई टू सॉल्व सम प्रॉब्लम, अप्लाई इट इन एस्ट्रोनॉमी, एंड उसके बाद यू कैन अप्लाई विथ रेफरेंसेस टू डिफरेंट मेनी इंस्टीट्यूट्स, एंड कहीं ना कहीं पे आपको ज़रूर ज़रूर एडमिशन या फिर जो भी आपका परसूट है वो आपको आप हासिल कर सकते हो. एम आई राइट प्रदीप? ये
Yes,
मैं
and I would say this
आप
is extendable to other fields as well, कि मतलब किसी भी फील्ड में आपको, like if you know कि you are interested in something, like let's say you are interested in robotics or something, then you do the projects that are related to that, no matter which branch you are in, you do the projects that are related to that, and मतलब पेड हो अनपेड हो कोई तो इंटर्नशिप करो, मतलब इंटर्नशिप करो, like every summer use the winter vacation as well, like summer winter vacations use करो to do these kind of projects, get experience. और जब हम लोग मतलब मेहनत करते हैं, like when you do that hard work of finding the internship and doing good work in that internship, you get like all these opportunities open up. मतलब ऐसा होता है ना कि एक डोर के अक्रॉस जाने की जरूरत होती है, उसके बाद बाकी के डोर्स like they open up by themselves, so you just have to do that hard work. So that is important. So yeah.
cool. So that is a very generalized thing, but that's what we actually discussed with his story, with Pradeep's story, and we are so glad that Pradeep was here, and Pradeep is here and he is sharing so much. I would really love for you, Pradeep, to come back and we will discuss जो भी हमने मिस किया होगा आज, we'll talk about it later.
Sure.
But
Yeah.
I think I have taken a lot of your time today. Sorry for that. But
No,
thank you so
It's
much to all the
it's a
viewers as well.
pleasure. Yeah, it's a pleasure. It's a pleasure talking to you, Deva, and really nice questions. And the audience also asked me really nice questions. So yeah, I'm very thankful for everyone who has joined. And yeah, thanks for arranging this.
Wait. You were cut off. Wait. Are you there?
Yes, I'm there.
Wait. I think you're
I'm
fluttering
still there.
and
I'm
I'm
still
also
there.
fluttering. Okay, जो भी लोग देख रहे हैं, like everybody, like people are saying let's call him again. So I'll set up, I'll ask him. बहुत अच्छे से पूछूंगा और लोगों को पसंद आया, जो भी लोग ठहरे उन सबको पसंद आया पॉडकास्ट. आई एम रियली हैप्पी अबाउट इट
Right.
बिकॉज कैसा है, ये हमारा जो चैनल है ना प्रदीप, इट वाज अबाउट करियर, लाइक एमटेक, उसके बाद क्या करना है. बट आई डोंट पर्सनली लाइक टू गो मच इनटू द डिटेल ऑफ एग्जाम्स, और एग्जाम्स कैसे क्रैक करनी है, कितनी देर पढ़ाई की. आई पर्सनली डोंट लाइक दैट. व्हाट आई लाइक टू डिस्कस अबाउट ऑल दीज थिंग्स, कि जो हम अभी बात कर रहे थे, और वो मैं और चाहता हूँ. But we will of course ask Pradeep again. And Pradeep, you were saying something, but I
About
interrupted.
the internships. मतलब हाँ, मैं तो यही कह रहा था कि like it's basically a domino effect, right? Like you start with one thing, and then the next opportunity for the next thing comes up with that, and then the opportunity for the next thing comes from that. So मतलब you have to get, अगर ऐसा लग रहा है कि मतलब कहीं नहीं जा रही है लाइफ, तो get started with something. Like you pour your hard work in something worthwhile, and opportunities will open up after that. Matlab, like let's say just do a course on Coursera and pour your efforts in it, or like do some internship somewhere, and do hard work there, so that you get like good amount of work out of it, you get good amount of experience out of it. Uske baad to matlab opportunities uske baad open hoti jayengi, like so you just have to work hard for whatever you are interested in, and opportunities will come. मतलब ऐसा लगता है कभी कभी, like if I remember 10 years down, मतलब 10 साल के पहले का अगर 2010 का अगर मैं सोचूं, तो 2010 में मतलब ये मैं सोच ही नहीं सकता था कि 10 साल बाद ऐसा कुछ होगा. Like it's
Yeah,
unimaginable, right? Like you can't imagine
true.
कि 10 साल बाद ऐसा कुछ होगा. But it happened, and that's just because you take the opportunities that come your way and do pour your hard work into it, and then new opportunities will come up. So that's how
Cool.
that's how you build your career.
Amazing, Pradeep. Thank you so much again. I'm really thankful to your time. और I'll ask you again. वो मैं तो कनेक्ट करूँगा, लेकिन सबके लिए, जो भी लोग आए, जिन्होंने देखा, जिन्होंने सवाल पूछे, जो लोगों ने क्यूरियोसिटी से ये सारा पॉडकास्ट देखा, एंड सबको थैंक यू. लाइक कर देना, इतना ही मांग रहा हूँ, लाइक कर देना, ज़्यादा से ज़्यादा लोगों तक पहुँचेगा. और जो इंटेंशन है हमारा वो सफल होगा, कि हाँ, ब्रिंगिंग समथिंग वैल्यूएबल फॉर यू. अगर आप ऐसे ही पॉडकास्ट चाहते हो तो सब्सक्राइब कर सकते हो चैनल को. मैं प्रदीप को भी फिर से बुलाऊंगा, और बाकी प्रदीप के दोस्तों को भी बुलाऊंगा इफ ही लव्स, एंड आई विल आस्क मेनी अदर पीपल जिनको सुन के आपको बहुत अच्छा लगेगा. आई विल ट्राई माई बेस्ट फॉर दैट. एंड पीपल आर ऑलरेडी सेइंग वी वांट हिम अगेन. सो ओके, I'll ask him nicely.
Awesome.
ताकि वो आए फिर से.
Yes. Of course, I'm happy to come again. Yeah, I'm happy to come again. Yeah,
Thank you
thank
so
you.
much.
Yeah.
Sure. I'll just but right now मैं पॉडकास्ट अभी एंड करूंगा, बिकॉज दिस इज अ गुड टाइम टू एंड इट विद सच अ पैशनेट आंसर जो प्रदीप ने लास्ट में दिया. प्लीज एक बार फिर से पॉडकास्ट देख सकते हो, मैं खुद भी देखूंगा. लेकिन जाते जाते बस इतना ही बोलूंगा कि मिलेंगे एक नए वीडियो के साथ जल्दी ही. तब तक के लिए ज्ञान पीते रहिए. आई एम एंडिंग द पॉडकास्ट दोस्तों. टाटा, बाय बाय.
Bye everyone.